We have started
We have
with
started with
our live
our
sessions
live
with
sessions with
the
the
introduction on
introduction
surface
on surface
engineering, why
engineering, like why
actually we
actually
do it,
we do it,
and like how
and
we
like how
can
we
mitigate
can
the
mitigate the
corrosion and
corrosion and
wear.
wear.
These are
These are
natural
natural phenomena which
occurring
are
with
occurring with
different
different
engineering
engineering
surfaces.
surfaces.
So
So
today is the
today
second
is the
live
second
session,
live
and
session,
I
and
welcome
I
you all
welcome you all
to the second
to
live
the second
session.
live session.
So in the
So in
past
the past
weeks
weeks
lectures,
lectures,
uh,
uh,
you mostly
you
have read
mostly have read
regarding
regarding
the wear
the
of
wear of
materials.
materials.
So
So
today's
today's
discussions will
discussions
be
will be
related to
related to
wear,
wear,
and
and
the
the
questions
questions
framed
framed
accordingly
accordingly
from different
from different
wear
wear
mechanisms, and
mechanisms,
how
and
we
how
can
we can
uh,
uh,
address the
address
issues
the issues
related to wear.
related to wear.
So coming to
So
the
coming
first
to the first
question,
question,
as you can
as
see
you
on the
can see on
screen,
the screen,
wear rate can
wear
be
rate can be
reduced by
reduced by
which of the
which of
following
the following
approaches?
approaches?
So
So
you can
you
unmute
can
yourselves
unmute
and
yourselves and
answer.
answer.
So wear
So
rate can
wear
be
rate can
reduced
be
by which
reduced
of the
by which of
following
the following
approaches?
approaches?
Improve
Improve
surface hardness
surface
and
hardness and
toughness,
toughness,
use
use
lubricants
lubricants
between mating
between mating
surfaces,
surface,
reduce
reduce
coefficient of
coefficient of
friction
friction
between
between
the sliding
the sliding
surfaces,
surfaces,
reduce the
reduce
surface
the
energy
surface
difference
energy
between the
difference
mating
between the mating
surfaces.
surfaces.
So
So
what would be the
what would be
correct
the
option
correct
here?
option here?
So as we know that
As
if
we
we
know that
increase
if
the
we increase
surface
the
hardness
surface
and
hardness and
toughness,
toughness,
obviously the wear
obviously the wear
resistance improves,
resistance
and
improves,
that's why
and
the
that's
rate
why
of
the
wear
rate of wear
reduces.
reduces.
So
So
first one
the
is a
first
correct
one is the
option.
correct option.
Lubricants
Lubricants
help in
help in
reducing the
reducing the
coefficient of
coefficient
friction,
of
and
friction, and
hence
hence
uh,
uh,
that
that
also helps in
also helps in
reducing wear rate.
reducing wear rate.
So that is also a
That is
correct
also a
option.
correct
So this
option.
is a
So this is
multiple
a
option
multiple
correct
option
type
correct
question.
type question.
Reduce the
Reduce the
coefficient of friction
coefficient of
between
friction between
sliding surfaces.
sliding
Yes, we
surfaces.
can
Yes, we
change
can
the
change the
topography of the
topography of the
surface,
surface,
and that may
and that
help
may
us in
help us
reducing
in
the
reducing the
coefficient
coefficient
of friction.
of friction.
Like in the
Like
last
in the
class
last
we
class we
discussed, we
discussed,
often
we
do
often do
laser surface
laser surface
texturing in
texturing
order
in
to
order to
reduce the
reduce the
contact area
contact
between
area
the
between the
sliding
sliding
surfaces.
surfaces,
And
and
suppose this is
suppose this
surface
is
1,
surface 1,
and you have
and you
another
have another
surface, say
surface, say,
like this,
like this,
which is having
which is
micro
having micro
asperities, but
asperities, but
these textures
these
are at
textures are at
mesoscale. I
mesoscale.
mean,
I
it's
mean,
not at
it's
micro
not at
scale, it's
micro scale,
larger
it's
than that.
larger than that.
So when
So when
this top
this
surface
top
is
surface is
sliding over
sliding
this
over this
textured
textured
surface, as you
surface,
can see
as you
that
can
the
see that the
contact is
contact is
obviously under the
obviously
action
under
of a
the action
normal
of a
load.
normal load.
So you can see
So
that
you
the
can see that the
contact
contact
points,
points,
the
the contact
between these
between these
two mating
two mating
surfaces
surfaces
is only
is only
established at
established at
selected points,
selected
whereas
points,
in
whereas
the
in
other
the other
regions there is
regions
no
there is
contact.
no contact.
So there's
So
one
there's one
probability that
probability that due to
the load
the
and
load and
due to a
due
higher
to a higher
contact pressure
contact
at this
pressure at
point,
this
these
point, these
surfaces tend
surfaces
to
tend to
um,
um,
adhere to each
adhere
other
to each other
by
by
cold
cold
welding at these
welding at this
points.
point.
However,
However,
suppose you apply
suppose you apply
some
some
lubricant here
lubricant here
between the two
between the two
surfaces, then
surfaces, then
there is a
there is a
possibility that due
possibility
to
that due to
hydrodynamic effects
hydrodynamic
of
effects of
lubrication,
lubrication,
this
this
top surface
top
tends to
surface tends
lift
to
off from
lift
the
off
bottom
from the
surface.
bottom surface.
So
So
a gap
a gap
is
is
established
established
spontaneously between the
spontaneously
two
between the two
surfaces
surfaces
due to
due to
the
the
hydrodynamic pressure.
hydrodynamic pressure.
So due to
So
this
due to this
gap, which
gap,
is
which is
essentially filled up
essentially
by
filled
the
up by the
lubricating fluid,
lubricating fluid,
you get
you get
reduced
reduced
contact between the
contact
two
between the two
surfaces, and
surfaces, and
obviously
obviously
the wear
the
rate will
wear rate
reduce.
will reduce.
So
So
likewise, we
likewise,
can
we can
like there are
like
other
there are other
approaches of
approaches of
reducing the
reducing the
coefficient of
coefficient
friction
of
also
friction
by
also by
putting some
putting some
additional
additional
phase elements
phase
on the
elements on the
surface,
surface,
some
some
other elements
other
which can
elements which
like
can
some
like
solid
some solid
lubricants,
lubricants,
molybdenum
molybdenum
sulfide.
sulfide.
If that is
If
being
that is
coated on
being
the
coated on
surface,
the
then it
surface,
helps
then
in
it helps
reducing
in
the
reducing the
coefficient of
coefficient
friction.
of friction.
So that
So that
ultimately helps in
ultimately helps in
reducing wear rate.
reducing wear rate.
And
And
what about the
what
fourth
about the
option?
fourth
What is
option?
your
What is
opinion
your
on this?
opinion on this?
Reduce the
Reduce
surface
the
energy
surface
difference
energy
between the
difference
mating
between the mating
surfaces.
surfaces.
Would it help
Would
in
it help in
reducing the wear
reducing
rate,
the wear
or
rate, or
would it lead
would it
to
lead to
a higher
a higher
rate of wear?
rate of wear?
Anyone, you can
Anyone,
answer.
you can answer.
I am audible,
I'm
right?
audible, right?
Yes, sir. Yes, sir.
Okay, okay.
Okay, okay.
So in between
So
the
in between the
connection gets a
connection
bit
gets a bit
shaky. That's
shaky.
why
That's why
I
I
always think.
think.
You are audible,
Yeah.
sir.
Okay. So
Okay. So
what is your
what is
answer?
your
What is
answer?
your
What
opinion
is your
about the
opinion
fourth
about the
option?
fourth option here?
So if we
So if we
reduce the
reduce
what
the what
role does the
role does
surface
the
energy
surface
play
energy
in
play in
increasing or
increasing or
reducing the wear?
reducing the wear?
See, if
See, if
you have two
you have two
surfaces, two
surfaces,
mating
two mating
surfaces.
surfaces.
This is
This
surface
is
one, and
surface
this
one,
is
and this
surface
is
two.
surface two.
And there
And
are
there are
interlocking of
interlocking of
asperities here. I'm
asperities
not
here. I'm not
showing that.
showing that.
So if
So
the
if
energy
the
difference,
energy
surface
difference,
energy
surface energy
difference is
difference is
higher,
higher,
that is
that is
gamma
gamma
1, this
one,
is gamma
this is
1 with
gamma one with
respect to
respect
air,
to
and this
air,
is
and this
gamma
is
2 with
gamma two
respect
with
to
respect to
air. I am
air. I am
assuming a dry
assuming a dry
condition
condition
between dry
between
sliding
dry
condition
sliding
between
condition
these two
between these
surfaces.
two
That's
surfaces.
why I
That's
am
why I am
considering air.
considering air.
So in
So
that
in
case,
that case,
if
if
the
the
surface energy
surface energy
difference is
difference is
higher,
higher,
then
then
the
the
addition
addition
is
is
not provoked
not provoked
in that
in
case.
that case.
So
So
if the
if the
if this
if this
difference is
difference is
high,
high,
then you have
then you
lower
have
addition,
lower addition,
lower chances
lower
of
chances
addition.
of addition.
Whereas if
Whereas
this
if
is
this
lower,
is lower,
that is
that is
both of the
both
surface
of the
energy
surface
are
energy are say both
surfaces are
surfaces are
having
having
same degree
same
of
degree of
hydrophilicity or
hydrophilicity
same
or
degree of
same degree of
hydrophobicity,
hydrophobicity,
then there are
then
more
there are
chances
more
of
chances
addition.
of addition.
So
So
as you can see,
as you
so
can see, so if they are
if the
adhering, if
surface
the
1 and
surface
surface
one
2
and
are
surface two are
adhering to each
adhering
other,
to each other,
then which type
then
of
which type of
wear can
wear
take
can
place?
take place?
It is severe.
Yeah,
Yeah,
adhesive wear. So
adhesive
what
wear. So
happens
what
in
happens
adhesive
in
wear?
adhesive
How
wear?
does it
How does it
propagates?
propagates?
Initially, the two
Initially, the two
surfaces will
surfaces will
tend to
tend to
interlock with each
interlock
other
with each other
through this
through this
cold
cold
weldments, and
weldments, and
yeah, you know, like
like
diffusion of
diffusion of
atoms take place,
atoms
and
take
that's
place,
why
and that's why there's
points of,
points of,
we can say,
we can
micro
say,
welds.
micro
So
welds. So
surface one
surface
will get
one will
welded
get
to
welded
surface
to
two
surface
at
two at
small
small
points.
points.
So
So
as the surface
as the
one
surface one
tries to
tries
slide
to
over it,
slide over it,
then this
then this
points break,
points break,
and some
and
weird
some
debris
weird debris
gets
gets
generated in
generated
between the
in
two
between the two
surfaces.
surfaces.
Now
Now
it
it
forms a three
forms a
body
three
weir
body wear
scenario.
scenario.
So in that
So in
cases,
that
these
cases,
small
these
small
small
particles can
particles
further
can further
degrade the
degrade the
surfaces.
surfaces.
They can
They
abrade
can
the
abrade the
surface. They can
surface.
erode
They
the
can erode
surface.
the
So
surface. So
and that is
and
how
that is how
it
it
results in higher
results in
wear rate.
higher wear rate.
So this is
So
not a
this is
right
not a
option,
right option,
correct option,
correct option,
because
because
we want
we want
a higher
a
difference
higher
in
difference
surface
in
energy,
surface energy,
so that
so that
the meeting
the meeting
surfaces don't
surfaces
tend to
don't
adhere
tend
to
to
each
adhere
other.
to each other.
Coming to the
Coming
next
to the
question,
next question,
fatigue failure may
fatigue
be
failure may be
minimized by which
minimized
of the
by which
following
of the following
approaches?
approaches?
Introducing surface
Introducing surface
roughness,
roughness,
introducing
introducing
residual
residual
compressive stress
compressive stress
on the
on the
surface,
surface,
applying a thin
applying
and
a
hard
thin and
coating by
hard coating by
PVD,
PVD,
and
and
electropolishing the
electropolishing the
surface.
surface.
So introducing residual compressive stress on the surface and applying a thin and hard coating by physical vapor deposition.
Okay,
Okay,
so
so
yeah, this
yeah,
question,
this question,
yeah.
yeah.
First
So
of all,
first of
if we
all,
try to
if we try to
understand what is
understand what
fatigue
is
failure,
fatigue failure,
then
then
like
like
in
in
fatigue failure, what
fatigue failure, what
happens
happens
at the
at the
surface?
surface?
So you're saying
You're
option
saying
B and
option
C.
B and
Option
C.
C is
Option
correct.
B is correct.
So
So
option C,
option C,
it's
it's
telling about
telling
physical
about
vapor
physical vapor
deposition.
deposition.
So if
So
we
if
do
we do
PVD,
PVD,
then there are
then
higher
there are
chances
higher
of
chances of
spalling occurring on
spalling
the
occurring on
surface.
the surface.
That is, you
That
have
is, you have
this layer,
this layer,
say L1.
say L1.
Sorry,
Sorry,
this is
this
the
is
coating
the
C,
coating C,
and this is your
and this is your
substrate S.
substrate S.
So you have an
So you have an
interface in
interface
between.
in between.
So generally
So
in
generally in
PVD, this
PVD, this
interface is not
interface is not
much strong.
much strong.
The
The
adhesion between
adhesion
the
between
C
the
and
C
S
and S
components here,
components here,
it's not
it's
very
not
high.
very high.
As a result,
As a result,
under
under
fatigue
fatigue
loading
loading
conditions, there are
conditions,
high
there are
chances
high
of
chances of
spalling occurring.
spalling occurring here.
So the
So the
coating will
coating will
tend to come
tend to
off
come off
the
the
substrate. So
substrate.
this is
So this
the
is
coating.
the
This is
coating.
the
This is
failure
the
of the
failure of the
interface.
interface.
I have
I have
exaggerated it, so
exaggerated
it
it. So
occurs
it
at
occurs
multiple
at
points
multiple
say,
points
under
under
fatigue loading
fatigue
conditions.
loading
So
conditions.
fatigue
So
I
fatigue
can
I can
show
show
like this.
like this.
I mean,
I
this
mean,
is just an
this is just an
indication.
indication.
This is not
This is
a
not a
standard
standard
denotion.
denotion.
So
So
yeah,
yeah,
this is
this is
interfacial failure.
interfacial failure.
So generally
So
under
generally
fatigue
under
loading
fatigue loading
conditions, we
conditions,
tend
we
to
tend
avoid
to avoid
such type of
such type of
coatings
coating
which may
which
fail due
may
to
fail due
spalling.
to spalling.
Okay.
Okay.
Yeah, we can
Yeah, we
put.
can put.
Yeah.
Yeah.
Yes, sir. Yes, sir.
Yes. Yes.
Yes. Yes.
So
So
we we
we we
we tend to
we
avoid
tend
it.
to avoid it.
So
So
your
your
option
option
B
B
is
is
correct
correct
here.
here.
Option
Option
C
C
is
is
not
not
correct.
correct.
So you need to
You
see
need to
which
see
type of
which type of
surface
surface
treatment has
treatment
been
has been
given in the
given in the
options.
options.
Had it
Had
been
it
some
been
other
some
type of
other type
coating
of
like
coating like
carburizing,
carburizing,
nitriding,
nitriding,
then you could have
then you
gone
could
with
have
that.
gone with that.
Then
Then
tempering,
tempering,
like carburizing followed by
carburizing followed by
tempering, then
tempering,
that will
then that
improve
will
the
improve the
toughness of the
toughness of
coating.
the
So
coating.
in that
So
case,
in
you
that
can
case, you
apply
can
it
apply it
under fatigue
under
loading
fatigue loading
conditions.
conditions.
Okay,
Okay,
so you can
so
see
you
a
can see a
component here.
component here.
So what are
So
the
what are
possible
the possible
degradation
degradation
mechanisms? So first
mechanisms?
of
So
all, what
first
is
of all,
this
what is
component?
this component?
It's easily
It's easily
identifiable. What is
identifiable.
this?
What is this?
So propeller.
Yes, it is
Yes, it is
a
a
boat or
boat
ship
or
propeller,
ship
you can
propeller,
say.
you can say.
Marine propeller.
Marine propeller.
So you can
So
see
you can
that its
see that
surface
its
is
surface
heavily
is
degraded.
heavily degraded.
So what
So
are the
what are
possible
the possible
degradation
degradation
mechanisms?
mechanisms here?
Yeah, what are the
What are the
possible
possible
degradation
degradation
mechanisms
mechanisms?
that you
So
can think of?
cavitation erosion.
Cavitation erosion.
Cavitation erosion.
Okay.
Okay.
Why does it
Why
occur?
does it occur?
So due to the presence of fluids which may eroded because so that the material will be eroded, so we get corrode. The material will get corrode.
So is the
Is
fluid
the
phase,
fluid phase,
sorry, is the
sorry,
liquid
is the
phase
liquid phase
responsible for
responsible for
cavitation?
cavitation?
Sir, as while in sea we can have like different salts, means like NaCl. Due to that,
No, no.
No, no.
First, let's
First,
discuss
let's
about
discuss about
cavitation erosion. It
cavitation
is the
erosion. It
correct
is the
option
correct
answer.
answer.
So that is one
So
of
that
the
is one of the
degradation
degradation
mechanisms. So why
mechanisms. So
does this
why does
happen?
this happen?
Like uh,
Uh,
cavitation
cavitation
erosion. So
erosion.
like
So
what are the
like what are the
possible
possible
causes of that?
causes of
I
that?
mean,
I mean,
what actually
what actually
happens
happens
during
during
cavitation erosion?
cavitation erosion?
So
So
this
this
impeller generally
impeller
rotates at
generally
a very
rotates
high
at a very
RPM,
high
right?
RPM, right?
It rotates
It
at a very
rotates at
high
a very
RPM.
high RPM.
So as a
So
result
as a
of
result
which
of which
there will be
there will be
regions of
regions of
low and high
low and
pressure.
high pressure.
So
So
near the
near the
propeller
propeller
blades,
blades,
the
the
there will be
there
some
will
low
be some
pressure
low
region.
pressure
So there
region. So there
the
the
liquid phase
liquid
turns
phase
into a
turns into
gaseous
a
phase,
gaseous phase,
vapor phase.
vapor phase.
So you will
So you
see
will see
bubbles
the
forming
bubbles
within
forming
that
within that
stream of
stream of
liquid, which is
liquid
being
which is being
propelled through which
through
the
which the
the ship is
the ship
propelling.
is
So
propelling.
this is your
So this is
propeller,
your propeller,
say,
say,
and it's
and
moving in
it's
this
moving in this
direction. So you will
direction. So
see
you will see a
bubbles here
bubbles
along
here
this line.
along this line.
So as these
So as
bubbles
these
are
bubbles
forming,
are forming,
uh,
uh,
like in the low
in the
pressure
low
zone,
pressure zone,
so as it
so as it
flows into the
flows
high
into the
pressure
high
zone, it
pressure zone, it
will
will
implode.
implode.
So we
So
say it
we
as an
say it as an
implosion of
implosion of
bubbles.
bubbles.
So why that
So why
happens
that
when
happens
in the
when
low
in the
pressure
low
zone,
pressure zone,
this liquid
this
can
liquid
sorry
can
the
sorry
water can
the water
easily
can easily
vaporize
vaporize
into
into
water vapor
water
and
vapor
form
and form
bubbles.
bubbles.
So
So
in
in
low
low
as it
as it
goes
goes
from low
from
pressure
low
zone to
pressure
high
zone to
pressure
high
zone,
pressure zone,
or
or
as the
as the
pressure
pressure
normalizes, so
normalizes,
there
so there
the
the
implosion of the
implosion of
bubbles
the
occur.
bubbles occur.
So due to the
So due to the
implosion,
implosion,
generally it
generally
occurs
it occurs
at the
at
surface
the
of
surface
this
of this
impeller.
impeller.
So
So
sorry, at the
sorry,
surface
at
of
the
this
surface of
propeller.
this propeller.
So
So
at that
at
time,
that
due
time,
to
due
the
to
shock
the
waves
shock
that are
waves that are
generated,
generated,
you will see
you
that
will see that
erosion is
erosion
happening.
is happening.
So that is
So
what
that is
we
what
call
we
as
call as
cavitation erosion.
cavitation erosion.
So there are
So there are
different
different
mechanisms to
mechanisms
avoid
to
this.
avoid
First
this.
of all,
First of
you
all,
can
you can
play with
play
the
with the
dynamics of the
dynamics
entire
of the
system.
entire
Like
system. Like
first of all, you
first
can
of all,
change
you
the
can change
design
the
of this
design of this
propeller itself.
propeller itself.
So
So
you design
you
the
design the
propeller in such
propeller
a
in
way
such a way
that
that
it's
it's
leading to
leading to
lower
lower
cavitation. You can't
cavitation. You can't
completely avoid
completely
it,
avoid
but
it, but
yeah, you can
yeah, you can
minimize it.
minimize it.
Second of all, you
Second of all,
can
you can
mm,
mm,
yeah, you can
yeah, you can
improve the
improve
material
the material
properties of this
properties of
propeller
this
so
propeller
that it
so
is
that
able
it
to
is able to
withstand that
withstand that
cavitation erosion.
cavitation erosion.
So one
So one
possibility is
possibility
you
is you
use thicker
use
propeller
thicker propeller
blades,
blades,
but that
but
will
that will
increase the weight
increase
of
the
the
weight of the
propeller, and
propeller,
as a
and
result,
as
the
a
power
result, the
required
power
to
required to
rotate it
rotate it
will be higher.
will be
So
higher.
power
So power
consumption will increase.
consumption
So
will
that is
increase. So
also
that is
not
also not
quite a
quite
feasible
a
option.
feasible option.
Third
Third
option, which
option
is left
which
with
is
you,
left with
is
you
you
is
can
you can
do some
do
surface
some surface
treatments
treatments
on this
on this
so that it is
so that
able
it is
to
able to
withstand this
withstand this
type of
type of
erosion.
erosion.
So
So
yeah, apart
yeah,
from
apart from
cavitation erosion,
cavitation
you are
erosion,
also
you are
telling
also
another
telling
type
another
of
type of
degradation
degradation
mechanism.
mechanism.
Now
Now
tell me what
tell
is
me
that?
what is that?
Yeah, what is the
Yeah,
what are the
what are the
other
other
possible
possible
degradation
degradation
mechanisms apart
mechanisms
from
apart from
cavitation?
cavitation?
So you are
So
saying
you are saying
something
something
regarding chloride
regarding
ion
chloride
ingress,
ion
right?
ingress, right?
So
So
this causes
this causes
corrosion.
corrosion.
That is
That
also
is
a
also a
degradation
degradation
mechanism.
mechanism.
So due to the
So due to
attack
the
by
attack
these
by
chloride
these chloride
ions,
ions,
uh,
uh,
it will
it
lead
will
to
lead
pitting
to
type of
pitting type of
effect on the
effect
surface,
on the
pitting
surface,
corrosion.
pitting corrosion.
And as
And
we had
as we
discussed
had
in the
discussed
last
in the
class,
last class,
this pitting
this
corrosion
pitting
is
corrosion
dangerous
is
because
dangerous
at the
because at
surface
the
you can
surface
see
you can see
small
small
pits,
pits,
and
and
that's it. But
that's it. But
beneath the
beneath the
pits, it
pits, it
generally
generally
there are
there
possible
are possible
regions of
regions of
crack
crack
initiation and
initiation and
propagation.
propagation.
So that is
So
not
that is
visible
not
to us,
visible to us,
and the
and
material
the
generally
material
fails
generally
from
fails
beneath.
from beneath.
So this part
So
will
this
come
part
off
will
if
come off
these two
if these
crack
two crack
lines
lines
join.
join.
So
So
this type of
this type of
corrosion is
corrosion is
something
something
we don't
we
want. So
don't
this
want. So this
pitting corrosion
pitting corrosion
happens.
happens.
Another
Another
possibility is
possibility is
marine
marine
biofouling.
biofouling.
So there
So
are
there
different
are
type of
different type of
organic
organic
species
species
in the
in the
uh,
uh,
marine
marine
environment,
environment,
like
like
algae
algae
and
and
bacterial species
bacterial
are
species
there.
are there.
So they will
So they will then
you know
you know
different type of
different type of
organisms
organisms
microorganisms, they will
microorganisms,
lead
they
to
will lead to
biofouling.
biofouling.
So as we
So
know that
as we know
when
that
the
when
bacteria
the
settles
bacteria
on
settles
any
on any
surface,
surface,
it will
it will
release some
release some
extra
extra
polymerase
polymerase
substance.
substance.
We also
We
call it
also
as
call it as
EPS,
EPS,
and
and
this EPS
this
is
EPS is
basically a
basically a
polymeric
polymeric
substance,
substance,
and it forms
and
a
it
layer
forms a
on top
layer
of
on top
this,
of this
you know,
you know
layer on
surface
top
layer
of
on top
this.
of this
What do we say? That
do we say,
propeller
that propeller
surface.
surface.
So as a
So
result,
as a
what
result,
happens
what happens
beneath this
beneath
layer?
this layer?
You will see
You will
that
see
the
that the
corrosion starts,
corrosion
and it
starts and it
aggravates
aggravates
very soon,
very soon,
and it's
and it's
difficult to
difficult to
uh,
uh,
address such type
address
of
such type
corrosion.
of corrosion.
So another,
So
to prevent that, what
prevent
we
that,
can
what
do
we can
is
do is
we
we
generally
generally
use
use
different
different
surface
surface
texturing
texturing
mechanisms.
mechanisms.
We can
We can
impose
impose
nanostructures on the
nanostructures on the
surface.
surface.
So there's a
So
lot of
there's a lot
research
of
going
research
on in
going
this
on in
domain,
this domain,
wherein
wherein
as the
as the
bacteria tries to
bacteria tries
settle
to
on this,
settle on this,
it will get
it will get
ruptured
ruptured
due to the
due to the
mechanical action by
mechanical
these
action by these
nanostructures,
nanostructures,
and it will
and it will
eventually die.
eventually die.
Another option
Another
is you
option is
can
you can
make the
make the
surface super
surface super
hydrophobic.
hydrophobic.
So
So
that helps in
that helps
self
in
cleaning.
self cleaning.
So again,
So again,
we can
we
make
can
the
make the
surface in such
surface
a way,
in
either
such a way, either
chemically or
chemically
like
or like
physically,
physically
changing the
changing the
topography. We can
topography. We can
impose a
impose
Cassie
a
Baxter
Cassie
state
Baxter
of
state of
wettability on the
wettability on
surface.
the
So
surface. So
what happens
what
that the
happens that the
contact angle is
contact
much
angle is
higher
much
here
higher
in
here
this
in
case,
this case,
as you can see.
as you can see.
The
The
contact angle
contact
is much
angle is
higher.
much higher.
So here
So here the
this
this
liquid bubble, as
liquid
you can
bubble,
see,
as
it
you
is
can see,
not
it is not
able to
able
spread
to
on the
spread on
surface,
the
as a
surface,
result
as a
of
result
which
of which
the
the
corrosion is
corrosion is
also less,
also less,
and the marine
and the marine
biofouling is
biofouling is
also
also
reduced in this
reduced in
case.
this case.
So these are some
These are some
possible
possible
remedies. One
remedies.
is
One
to
is
avoid
to
erosion.
avoid
You can
erosion. You can
put some
put
hard
some
coating,
hard coating,
which improves
which
the
improves
hardness
the
and
hardness
toughness
and
of the
toughness of the
surface.
surface.
And second,
And second,
to prevent
to prevent
corrosion and marine
corrosion and marine
biofouling, you
biofouling,
can
you
also
can
use
also
some
use some
coatings
coatings
which will
which
prevent
will
the
prevent the
corrosion to
corrosion
happen.
to
Some
happen. Some
polymeric coatings,
polymeric
or
coatings,
some
or some even
ceramic coatings,
ceramic
which will
coatings, which
prevent
will
the
prevent the
corrosion.
corrosion.
And for
And
marine,
for
and
marine,
also along
and
with
also
that, you
along
can
with that,
use
you can
this
use this
topography
topography
oriented
oriented
mechanisms.
mechanisms.
Okay, so any
Okay, so any
questions
questions
regarding this?
regarding this?
Like,
Like,
if do you have any
do you
other
have any other
suggestions, like any
suggestions,
other
like
type
any
of
other type of
degradation occurring
degradation
here,
occurring here,
and any
and
other
any other
remedies?
remedies?
Yeah, anyone?
Yeah, anyone?
Okay, so I
Okay,
will move
so
to
I
the
will
next
move to the
question.
next
This
question.
is
This
what we
is
call
what we call
bacterial
bacterial
contact killing.
contact killing.
Okay. Okay, so
Okay, so
another similar
another similar
question.
question.
So here you can
So here
see
you
a
can see
gear.
a gear.
You can see
You can see
some
some
type of wear
type of
which has
wear which
happened.
has happened.
So
So
yeah,
yeah,
what are the
what are the
possible
possible
mechanisms of wear
mechanisms
here?
of wear here?
Identify the type
Identify the
of wear
type
in
of
the
wear
shown
in the
component.
shown component.
So what do
So
you think
what do
can
you
be
think can be the
probable
probable
wear
wear
mechanisms?
mechanisms?
You can just
You can
make a
just
guess.
make a
Like
guess,
try
like
to
try to
think
think
how this
how
surface
this
is being
surface is being
engaged in
engaged in
a
a
mechanical action.
mechanical action.
What type of
What type of
loads are
loads
acting
are
on
acting on
the gear
the
tooth?
gear tooth?
Yeah, so
Yeah,
just
so just
you know
you know
try to address
try
this
to address
question
this
from
question
here.
from here.
Like, what are the
Like, what are the
possible causes
possible
of
causes of
the wear?
the wear?
First, try to
First,
answer
try to
this
answer
question.
this question.
Next, you
Next, you
identify.
identify.
Third, you
Third, you
tell me the
tell me the
engineering
engineering
approaches.
approaches.
Yeah, Arun,
Yeah, Arun,
Likita,
Likita,
anyone?
anyone?
Okay, so this
Okay,
is
so
a
this is
pitting
a
type
pitting
type of wear,
type of
right?
wear, right?
You can see
You can
small
see
small
small
pits
small
over
pits
here.
over here.
So this is
So this
pitting
is
wear.
pitting wear.
What are the
What are
causes
the
of this
causes of
pitting
this
wear?
pitting wear?
What are the
What are the
causes for
causes
such
for
type of
such
wear?
type of wear?
So
So
you should
you
have
should have
loading
a loading
condition which may
condition
lead
which
to
may lead
fatigue.
to fatigue.
So you have
So you have
fluctuating load.
fluctuating load.
Why
Why
fluctuating?
fluctuating?
Because
Because
the gear
the
teeth,
gear
if you
teeth,
take
if you
each
take
gear
each
teeth,
gear teeth,
it's
it's
engaging and
engaging and
disengaging.
disengaging.
And this
And
happens
this
in a
happens in a
cyclic manner.
cyclic manner.
And hence,
And
if you
hence,
see
if
the
you see
load
the
profile,
load profile,
then the load
then the
will
load will
increase,
increase,
again becomes
again
zero,
becomes
again
zero,
increase,
again
again
increase,
becomes
again
zero.
becomes zero.
So
So
this is like
this
a
is like a
typical
typical
loading
loading
cycle, you can
cycle,
say.
you can say.
And what is
And
the
what
type
is
of
the
load
type
here?
of
Is it
load here? Is it
compressive or
compressive or
tensile
tensile
or shear?
or shear?
What type of
What
load
type
is
of load
acting
is
on the
acting
gear
on the
tooth
gear
here?
tooth here?
It is
It is
compressive load.
compressive load.
So
So
yeah, right.
yeah, right.
So
So
it's
it's
attaining a
attaining a
maximum value and
maximum
again
value and
becoming
again
zero as
becoming
a
zero.
result
As a
of this
result
type
of
of
this type of
fatigue loading.
fatigue loading,
Pitting wear is
pitting wear
occurring.
is occurring.
So
So
like how does
how
this
does this
you know
you know
what is the
what is the
underlying
underlying
mechanism of
mechanism
the
of the
proceeding of
proceeding
such
of
type of
such
wear?
type of wear?
What happens
What
actually?
happens actually?
So
So
there will be,
there will
say,
be,
another
say, another
surface.
surface.
I'm just
I'm
roughly
just
drawing it.
roughly drawing it.
Say
Say
these are two
these are two
gears
gears
which are meeting.
which are mating.
So at
So
this,
at this,
if we see
if
at
we see at
like this is
like this
say
is say
driving gear and
driving
this is
gear
the
and this is
driven
the
gear.
driven gear.
Okay.
Okay.
So this will be
So this will
applying
be
load here.
applying load here.
Consequently, this will
Consequently,
be
this
moving.
will be
So
moving. So
it will
it
start
will
from a
start
load
from a
value
load
and
value
it will
and it will
again become
again
zero.
become
Again, it
zero.
will
Again,
start
it
from
will
a load
start from a
value and
load
again
value and
become
again
zero.
become
So
zero. So
likewise, the
likewise, the
loading will
loading
take
will
place.
take place.
So at this
So at this
surface,
surface,
the you can
the
see
you can
that
see that along with
the normal
the
load,
normal load, along with the normal
normal
load.
means it
Normal means it
is acting
is
normal to
acting
the
normal to the
surface.
surface.
Along with the
Along with
normal
the
load,
normal load,
a
a
tangential load is
tangential
also
load is
there,
also there.
and
And this comes
this comes along
along
with
with
Friction.
Friction.
Friction. Why?
Friction. Why?
Because these two
Because these two
surfaces are
surfaces are
sliding.
sliding.
If you
If
just
you
look
just
at
look at
this
this
portion
portion
here,
here,
along with
along with
like
like
as this
as
gears
these
are
gears are
rotating,
rotating,
this
this
at this
at
point
this
there is
point there
relative
is
sliding
relative
between
sliding
these
between these two
surfaces,
surfaces,
and this
and
happens
this
at
happens at
pretty high
pretty high
speeds.
speeds.
So due to
So
these
due to
two
these two
conditions,
conditions,
you can see
you can see
small
small
pits or
pits or
small
small
localized
localized
failure of
failure of
material happening
material
at the
happening at
surface.
the
So
surface.
this
So this
initially
initially
initiates with
initiates
a
with a
small crack
small crack
at some
at some
deformities or
deformities or
dislocations of the
dislocations on the
surface
surface
or some
or some
impurities,
impurities,
and that
and that
small crack
small crack it
propagates
propagates
due to
due
the
to the
fatigue loading
fatigue loading
condition,
condition,
and
and
because of that
because of that
the material
the material
gets
gets
eroded from the
eroded from the
it gets
it
removed
gets
from the
removed from
surface
the surface
due to
due
chipping
to
chipping action.
chipping action.
So what
So what
surface engineering
surface engineering
approaches would you
approaches would
suggest to
you
prevent
suggest to
such wear?
prevent such wear?
Yeah, what
What
possible surface
possible
engineering
surface engineering
approaches? We
approaches? We
generally
generally
use
use
case
case
hardening
hardening
on the
on
on this
on this
surface. We
surface.
do
We
case
do
hardening,
case hardening,
then
then
carburizing,
carburizing,
nitrating, all those
nitrating,
things
all
are
those
there. So
things
we
are there. So
generally
we
try to
generally try to
increase the
increase the
hardness
hardness
and the
and the
toughness,
toughness.
since it is a
Since it is
fatigue
a
type of
fatigue
wear.
type of wear,
So that's
so
why
that's
both
why
needs to
both
be
needs to be
improved,
improved,
both the
both
hardness
the
and
hardness and
toughness. Case
toughness. Case
hardening, then
hardening, then
some heat
some
treatment.
heat
It should be
treatment. It should
followed
be
by
followed
some
by some
tempering and all.
tempering and all.
So heat
So heat
treatments.
treatments.
Okay.
Okay.
So any
So
question
any
from here?
question from here?
Doubt?
Doubt?
So shall we
Shall
proceed to
we
the next
proceed to the
question?
next question?
Okay.
Okay.
Name some
Name some
possible
possible
reasons for
reasons
crack
for crack
initiation on
initiation
a
on
surface
a
under the
surface
action
under
of
the
a
action
load.
of a load.
So why does
So
a
why
crack
does a
initiate?
crack initiate?
You have a
You
given
have a
loading
given loading
condition, say.
condition, say.
Say it's a
Say it's a
compressive load, or
compressive
it's
load, or
a
it's a
cyclic load,
cyclic
or it's
load,
a
or it's a
tensile load.
tensile load.
So what
So what
characteristics on the
characteristics on the
surface
surface
would
would
invoke the
invoke the
initiation of a
initiation
crack?
of a crack?
So if
So
you
if you
look at the
look at the
surface, there
surface,
will be
there
some
will be some
defects.
defects.
Porosity.
Yeah.
Yeah.
So
So
it can be
it can be
surface defects
surface
which you can
defects which
see
you can
just at
see
the
just at the
surface,
surface,
or it can be
or it can be
subsurface
subsurface
defects.
defects.
Subsurface means it
Subsurface means
is
it is
present under
present under
beneath the
beneath
surface,
the surface, beneath the top
and
surface, and
this is
this
sometimes
sometimes
porosity is also
porosity is
there
also
beneath the
there beneath
surface.
the surface.
So up to a few
Up to a few
nanometers, you have a
nanometers, you have
porous
a
layer.
porous layer.
So in
So
that
in
case,
that case, the
there is high
there is high
possibility that the
possibility that the
microcracks start
microcracks start
initiating from this
initiating from this
porosity
porosity
rather
rather
than
than
from the
from the
surface alone.
surface alone.
So
So
porosity,
porosity,
then
then
impurities.
impurities.
So what
So
happens
what
if you have
happens
an
if you have an
impurity
impurity
and a
and
different
a
phase
different
here?
phase
So
here?
at
So
the
at the
boundary, you have
boundary, you
high
have high
surface energy
surface energy
region.
region.
So
So
there are
there are
you know
you know
chances that the
chances
crack
that the
initiates
crack
from this
initiates from
boundary.
this boundary.
Then
Then
some
some
dislocations can be
dislocations can
present.
be present.
defects and
defects and
dislocations,
dislocations,
we can
we can
put them under the
put them
same
under the
category.
same
And
category. And
yeah, apart
yeah,
from
apart
this,
from this,
any other
any other
from the
from the
geometrical point
geometrical
of view,
point
can
of
you
view, can you
name a
name a
few
few
causes of
causes
this
of this
crack initiation
crack
from
initiation
design
from
point of
design
view?
point of view?
So these are
So these are
metallurgical things, right?
metallurgical things, right?
So
So
you can have
you can
stress
have stress
concentration
concentration
points.
points.
So
So
if you have
if you
seen
have seen
water
water
reservoirs,
reservoirs,
have you seen
have
water
you seen water
reservoirs on
reservoirs on an
overhead water
overhead water
tanks?
tank?
So you can see
So you can
that
see that
their
their
corners are
corners are
generally
generally
not sharp.
not
They are
sharp.
made
They are made
uh, with a
with a
finite
finite
radius. They're
radius.
given a
They're given
finite
a finite
radius over here.
radius over here.
So this is
So this
done
is
to
done to
prevent the stress
prevent the stress
concentration at these
concentration at
corner
these corner
points.
points.
Otherwise, over
Otherwise,
the
over
time,
the time,
there's high
there's high
chances that
chances that
the crack
the crack
initiates and
initiates and
under the
under
loading
the loading
conditions, and it
conditions, and it
propagates to
propagates
these
to
corner
these corner
points.
points.
So
So
here stress
here stress
concentration
concentration
occurs.
occurs.
It's corner points.
Corner points.
Again,
Again,
similarly, if you
similarly, if you
look at some
look at some
components, say
components, say
this is
this
an
is an
engineering
engineering
component,
component,
and
and
you're having
you're
a
having a like
this
this
component, it's
component,
a
it's a
rectangular bar,
rectangular
say,
bar, say,
with a
with a
circular hole in
circular
between,
hole in
oval
between,
hole in
oval
between.
hole in between.
So due to
So
this
due to
oval
this
hole,
oval hole,
what
what
happens
happens
when you are
when you are
applying the
applying the
stress?
stress?
Then at this
Then at this
particular cross
particular
section,
cross section,
only this
only
much
this much
material is
material
like,
is like
if you
if you
see along the
see
cross
along the
section,
cross
only
section,
this
only
much
this
material
much
is
material is
resisting the motion.
resisting the motion.
Sorry, resisting
Sorry,
the
resisting the
load,
load,
right?
right?
While if you
While
see
if you see
this
this
cross section,
cross
then this
section, then
entire
this
cross
entire
section is
cross section
resisting
is
the load.
resisting the load.
As a
As
result
a
of
result
which,
of which,
above this
about
points,
these
there will
points,
be
there will be
stress
stress
concentration
concentration
regions.
regions.
So as a
So
result,
as a result,
we
we
generally try
generally
to
try to
avoid such
avoid
type of
such type
designs
of
where
designs
there
where
can be
there can be
possible points
possible
of
points
stress
of stress
concentration,
concentration,
because
because
crack
crack
generally initiates
generally
from
initiates
such
from
points.
such points.
Okay,
Okay,
so which
so
of the
which
following
of the following
statements
statements
is or
is
are
or are
false regarding
false
the
regarding
fatigue
the
of a
fatigue of a
component?
component?
It occurs
It occurs
under
under
cyclic loading
cyclic loading
conditions.
conditions.
Residual tensile
Residual
stresses
tensile
help in
stresses help
improving
in
the fatigue
improving the fatigue
performance of the
performance
material.
of the material.
Crack propagates
Crack
at a very
propagates
high
at a
rate
very high rate
right after the
right after the
initiation.
initiation.
Crack
Crack
initially
initially
proceeds along the
proceeds along the
crystallography,
crystallography,
closed pack
closed pack
directions.
directions.
So
So
you have to
you have
identify
to
the false
identify the false
statements.
statements.
So residual tensile stress helps in improving the fatigue performance of the material.
Okay,
Okay,
so
so
generally
generally
residual
residual
compressive stresses
compressive
help in.
stresses help in.
So why so?
So why so?
Why?
Why?
What
What
happens under the
happens
action
under the
of
action of
tensile
tensile
stress
stress
during the
during
crack
the crack
propagation?
propagation?
So crack
So
widening
crack
takes
widening
place
takes place
during
during
tensile
tensile
component of the
component
loading.
of the loading.
The length
The length
increases, crack
increases, crack
propagation length
propagation length
increases.
increases.
And what
And
happens
what
during
happens during
compressive loading?
compressive
This
loading?
happens
This
during
happens during
tensile
tensile
component of the
component
loading.
of the
During the
loading. During the
compressive component
compressive
of the
component
loading,
of the loading,
this
this
crack
crack
closure takes
closure
place.
takes place.
As a result,
As a
we
result,
want
we
some
want some
residual.
residual.
Therefore, we want
Therefore, we
some
want some
residual
residual
compressive load.
compressive load.
So from
So
the
from
beginning
the
only, we
beginning
will
only, we will
provide some
provide some
compressive load so
compressive
that
load so that
closes the crack,
closes the crack,
or it
or
rather
it rather you know
prevents the crack
prevents the
from
crack
widening.
from
So
widening.
it will
So it
prevent
will
the crack
prevent the
widening.
crack widening.
So yeah,
So
is that
yeah,
the
is
only
that the
wrong
only wrong
option here?
option here?
So if you see
If you see the
third
third
option,
option,
it
it
propagates at a
propagates
very
at a
high
very
rate
high
right
rate
after
right after
initiation.
initiation.
So is
So
this
is
correct?
this correct?
So during fatigue
During
failure,
fatigue
if you
failure,
recall
if you recall
correctly,
correctly,
there will be
there
two
will be two
stages
stages
generally.
generally.
Like I am
Like
talking
I am
about the
talking
crack
about the crack
propagation part.
propagation part.
First, it will
First, it will
initiate.
initiate.
Then,
Then,
during the
during the
propagation part, there
propagation
will be
part,
two
there will be two
stages.
stages.
So, at the
So
first
at the
stage, you
first
will
stage,
see
you will see
only
only
subsurface, say
subsurface, say up to
a few
a few
nanometers or few
nanometers or few
microns
microns
depth.
depth.
The crack
The
will
crack will
propagate at a very
propagate at a
slower
very
rate
slower rate
through the
through the
crystallographically closed
crystallographically
pack
closed pack
directions. It will
directions. It
proceed
will proceed
across the
across the
grains,
grains,
and the grain
and the
boundaries
grain
up to
boundaries up to
only say two
only
three
say
layer
two
of
three layer
grains.
of grains.
Beyond that,
Beyond that,
so this will be
so this will
happening
be
at
happening at
very slow
very
and
slow and
controllable
controllable
rate.
rate.
But
But
beyond a
beyond a
critical value,
critical value
or beyond a
or beyond the
critical
critical
crack length, you
crack
can
length,
say,
you can say,
the crack
the crack
begins to
begins
propagate
to
at a
propagate at a
uncontrollable and very
uncontrollable and
high
very high
rate,
rate,
very
very
fast rate.
fast rate.
So right
So
after
right after
initiation, you won't
initiation, you
see
won't
stage
see
2.
stage two.
You will
You will
right after
right after
initiation you will see
initiation, you will
stage
see
1,
stage one,
and beyond the
and beyond
critical
the
value
critical
of
value
crack
of
length,
crack
when
length,
L is
when
greater
L is
than
greater than
LC,
LC,
this L,
this L,
only then
only
you
then
will
you will
see
see
the
the
phenomena of
phenomena
very
of
high rate
very high rate
crack
crack
propagation.
propagation.
So this is
So this
also
is also
a
a
false
false
option,
option,
false statement
false
rather.
statement rather.
Okay,
Okay,
coming to the
coming
next
to the
question,
next question,
Archer's
Archer's
equation
equation
relates wear
relates
rate
wear
with
rate
which
with
of the
which of
following?
the following?
Material
Material
parameters,
parameters,
hardness,
hardness,
sliding distance
sliding
and load,
distance and load,
magnitude and
magnitude
vector
and
of
vector of
stress,
stress,
toughness of
toughness
material.
of material.
First of all, you
First of
need to
all,
be
you need to
clear
be
that
clear that
wear rate
wear rate
depends on all
depends
of
on
these
all of these
properties.
properties.
It depends
It
on the
depends on
material
the material
parameters,
parameters,
generally the
generally
surface
the surface
parameters.
parameters.
Then it
Then
depends
it
on the
depends on
toughness
the
of the
toughness of the
material. It
material.
depends
It
on
depends
the
on the
magnitude, that is
magnitude, that is
amplitude. Vector
amplitude,
means the
vector means the
direction and all
direction and all
of stress.
of stress.
It also
It
depends
also
on the
depends on the
hardness of the
hardness of the
surface,
surface,
sliding
sliding
distance and load.
distance and load.
But
But
if you
if you
notice
notice
Archer's
Archer's
equation,
equation,
it will
it
only
will
relate
only
these
relate
three
these three
parameters
parameters
with
with
wear rate.
wear rate.
So,
So,
so
so
volumetric generally
volumetric
it's
generally it's
denoted by V.
denoted by V.
It's
It's
directly
directly
proportional to the
proportional
load.
to the load,
It's directly
directly
proportional to the
proportional to the
sliding distance,
sliding
say
distance,
S,
say S,
but it's
but it's
inversely
inversely
proportional to the
proportional to the
hardness.
hardness.
So
So
you get
you get
something like
something
this,
like this,
where K
where
is
K
the
is the
proportionality
proportionality
constant.
constant.
It depends
It
on
depends on
the
the
sliding
sliding
conditions.
conditions.
So whether
So
you're
whether you
having
are
a
having
abrasive
a
type of
abrasive type
wear,
of wear.
okay. So
Okay, so
can you just
can
tell
you
me
just
one
tell
thing?
me one thing?
You
You
try to
try
imagine
to imagine
this is
this
say
is
one
say one
surface
surface
S1, and
S1
you have
and you have
another
another
mating surface
mating
S2.
surface S2.
Suppose this is
Suppose this
sliding
is
over
sliding
this
over this
surface S1.
surface S1.
S1 is at
S1 is
rest.
at rest.
So under
So
these
under these
conditions, just
conditions,
look at
just
this
look at this
equation.
equation.
So
So
it's saying that
it's saying
higher
that
the
higher the
sliding
sliding
distance.
distance.
So suppose it
So
is
suppose it is
sliding
sliding
from say
from
point
say
1
point
to
1
point
to
2
point 2
in one
in
case,
one case,
and say from
and say
point
from
1 to
point 1
point
to
3
point 3
in another
in
case.
another case.
So this
So
is
this is
say
say
S1,
S1,
and this is
and
say
this is
S2.
say S2.
Okay,
Okay,
or rather I
or
can say
rather I
as
can say as
S13 and
S13 and
S12.
S12.
So you can see
So
that
you can see that
S12 is greater
S12
than
is greater than
S13.
S13.
So
So
why do we
why
say
do we
that
say
if
that
the
if the
sliding
sliding
distance is
distance
more
is
than the
more than the
wear rate will
wear
be
rate
more?
will be more?
Why so?
Why so?
It's a very
It's a very
intuitive,
intuitive,
the answer is
the
very
answer is very
intuitive. You
intuitive. You
need not have
need
to
not have to
know
know
much about the
much about the
equation and all.
equation and all.
But just
But
if
just
you just
if you
look
just
at this
look at this
scenario
scenario
and try to
and try
recall
to
what
recall what
happens
happens
when two
when two
surfaces are
surfaces
meeting,
are meeting.
just
Just
try to
try
imagine
to
and say
imagine
why
and say
on
why on
increasing the
increasing the
sliding distance
sliding
the wear
distance
rate
the
is
wear rate is
increasing.
increased.
So because the contact time is more, so
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 say I have
say I have
equalized the
equalized the
contact time.
contact
So
time. So
from point
from
1 to
point
point
one
2
to
I am
point two, I
moving
am moving
at a
at
higher
a higher
velocity,
velocity,
and I am
and I
covering
am
it in say
covering it
1
in say
second.
1
From
second.
point
From
1 to
point
point
one
3
to
I am
point three,
moving
I
at a
am
lower
moving at a lower
velocity and
velocity
covering
and
it in 1
covering it in
second.
1 second.
Then what
Then
happens?
what happens?
Like the
Like
speed
the
in both
speed in
cases are
both cases
different.
are different.
You're
You're
allowing the same
allowing the same
contact time.
contact time.
So it's
So it's
obvious, right? If
obvious,
you
right? If
increase
you
the
increase
speed,
the speed,
um,
um,
the wear rate
the
will
wear rate will
increase.
increase.
Because if you
Because
look
if
at
you
the
look at
surface,
the
if you
surface,
look at the
if you look at the
contact at
contact
these two
at these two
surfaces,
surfaces,
generally,
generally,
if
if it's
adhesive type of
adhesive type of
failure or
failure
adhesive
or
type of
adhesive type of
wear is
wear
occurring,
is occurring,
so
so
some wear
some
debris
wear
will be
debris will be
generated.
generated.
So you are
So you are
sliding this wear
sliding this
debris
wear
up to a
debris up
larger
to a larger
distance in case
distance
of
in case of
S12.
S12.
As a result
As a result
of which
of which the
you're
you're
giving, yeah,
giving,
your
yeah,
answer is
your
also
answer is
correct
also
that
correct that
the
the
contact time is
contact
higher.
time is
So
higher. So
the wear
the wear
debris are
debris are
uh,
it
it is
is
abrading the
abrading
surface
the
as well
surface
as
as well as the
this
this
slider
slider
for a longer
for a
period
longer
of time or
period of
for a
time or
larger
for a larger
distance.
distance.
While in
While in
1-3 it's
one
for
three,
a
it's for a
smaller distance
smaller
and smaller
distance and
period of
smaller
time,
period of time,
as you may say.
as you may say.
So in
So
that
in that
line of thought, we
line of
can say
thought, we
that
can
yeah,
say
it's
that, yeah,
directly
it's directly
proportional to
proportional
S.
to S.
And obviously
And
if the
obviously,
load
if the
is
load
higher,
is
then
higher,
also
then
the
also
wear
the
rate will
wear rate will
increase.
increase.
Okay, so
Okay, so
another question.
another
Suppose
question.
after
Suppose
the
after
sliding
the
test,
sliding test,
so after
so after
sliding this,
sliding this,
if you look
if
at
you
the
look at
surface,
the surface,
so
so
typically you will
typically
have
you will
a
have a
zone like
zone
this.
like this. Say
So from point
from
1 to
point
point
one
2,
to
you have
point
done
two, you
some
have done
sliding
some
test.
sliding test.
Yeah.
Yeah.
So from
So
point 1
from
to
point
point
one
2, you
to
have
point
done
two, you have
some
done some
sliding test.
sliding test.
And yeah,
And
how can
yeah,
you
how can you
characterize this
characterize this
surface?
surface?
What are the
What are the
possible
possible
characterization
characterization
techniques?
techniques?
You know
You know
characterization, right? How
characterization, right?
to
How to
understand what type
understand
of
what
wear
type
has
of wear has
happened, how
happened,
to
how to
see
see
what phases
what
have
phases
formed on
have
the
formed on the
surface.
surface.
So that's what
So
we
that's
call as
what we call as
characterization.
characterization.
So
So
generally,
generally,
when you do
when you do
some
some
wear test,
weird test,
like you have
like you have
conducted some
conducted some
experiments
experiments
related to
related to
wear.
wear.
So in that
So
case,
in
what
that
you do
case,
is
what you do is
um,
um,
first you try to
first you
see
try
the
to see the
surface at
surface at
microscopic level.
microscopic level.
This particular
This
surface
particular
you
surface
try
you
to
try to
see under
see
SEM,
under SEM,
scanning electron
scanning electron
microscope, and
microscope, and
like see what
like see
type of
what type of
more wear
more wear
morphology is
morphology
forming.
is forming.
So
So
this is
this
the
is the
like
like
surface before
surface
wear, and
before
this is
wear,
the
and this
surface
is the
after
surface
wear. So
after
what are
wear.
the
So what are the
changes in
changes in
micro or nano
micro or
scales
nano scales
at this surface?
at this
Generally, we
surface?
see
Generally,
at
we see
micro
at
scales.
micro scales.
Next is,
Next is,
so if we
so
try to
if we try to
calculate the
calculate the
actual wear
actual
volume,
wear
so
volume,
this
so this
will give me
will
the
give me the
rate of
rate of
mm,
volumetric
volumetric wear
wear for
for time t, say
time t.
I
Say
have
I have
conducted this for
conducted this
time
for
t, then
time t. Then accordingly
I can
I
multiply
can
that and
multiply
get
that
for
and get
this
for
much
this much
interaction time I
interaction
have
time I have
lost this much
lost this
volume
much
of
volume
material.
of material.
But if you
But
want
if
to
you want to
actually
actually
calculate that the
calculate that the
volume loss
volume
that
loss
has
that
happened,
has happened,
then you can
then
do
you can do
some
some
optical
optical
3D optical
3D optical
profilometry.
profilometry.
So I'm just
So I'm just
listing this
listing
out
this
so that
out so that
in future,
in
if
future, if
some of you
some of you
are pursuing
are
higher
pursuing
studies,
higher
then
studies, then
you can
you
have this
can have this
as an
as an
experiment or as a
experiment or as
project.
a project.
So that's why
So
I'm
that's why
just
I'm just
elaborating on this.
elaborating on this.
So under
So
3D
under
optical
3D optical
profilometry, again you
profilometry,
have
again you have
different
different
approaches.
approaches.
So another
So
approach
another
can be
approach can
laser
be laser
confocal laser
confocal laser
scanning
scanning
microscopy.
microscopy.
So that
So
will
that will
help you to
help you to
evaluate the wear
evaluate the
volume.
wear volume.
This will
This will
help you
help you
calculate the wear
calculate the
volume.
wear volume.
I won't say
I won't say
calculate, rather
calculate,
measure
rather
the wear
measure the
volume
wear volume
to a
to a
fairly
fairly
accurate
accurate
with
with
fair accuracy.
accuracy.
Okay, so
Okay,
it
so
will
it
obviously
will
be more
obviously be
accurate
more
than what you
accurate
have
than what you have
estimated using
estimated using
this
this
equation,
equation,
because in
because
real
in the real
scenario you will
scenario
see
you will
that
see that more wear
there are chances
there are
of
chances
more
of
wear
more wear
near the
near the
ends
ends
or at
or
the
at
center.
the center.
So
So
under different
under
loading
different loading
conditions, this
conditions,
thing can
this thing
happen,
can
because
happen, because
you have
you
one
have one
uh,
uh,
this
this
indenter, or what
indenter,
we
or
call
what we
as
call as
the
the
slider.
slider.
So due to the
So due to the
inertial effects of
inertial
the
effects of the
slider at the
slider at the
corners,
corners,
there can be
there can
either
be
more
either
wear
more
or
wear
there can
or
be
there
less
can be
wear,
less wear,
depending upon
depending
the
upon the
this debris
this debris
particles. So the
particles.
debris
So the debris
particles may
particles
get
may get
deposited at the
deposited at
ends.
the ends.
So in that
So in
case,
that case,
the wear
the wear
morphology will be
morphology will
different
be
at the
different
ends
at the
than
ends
at
than
the center.
at the
So
center.
as a
So
result,
as a
it's
result, it's
not
not
necessarily you will
necessarily you
get
will
a
get a
uh,
uh,
this weird
this
track of
weird track of
same cross
same
section
cross section
throughout.
throughout.
So that cross
So that
section may
cross
change
section may
along the
change
length.
along the length.
So yeah,
So yeah,
you can use
you can
this
use this
optical
optical
profilometric
profilometric
approaches to
approaches
measure
to
the wear
measure the
volume.
wear volume.
So third
So
is to
third
see
is
if
to see if
any
any
particular phases
particular
have
phases
formed
have formed
here or not.
here or not.
Say
Say
like
like
you are
you are
sliding
sliding
of a
of a
particular
particular
material of
material of
a slider of
a slider
particular
of particular
material on a
material on
surface
a
of
surface
another
of another
particular material.
particular material.
Apart from
Apart
those
from
two
those two
uh,
uh,
surfaces,
surfaces,
you are getting
you are
some
getting
weird
some
debris
weird
as the
debris as
third
the third
component. So
component. So
you can
you can
identify what
identify
is
what
the
is
nature
the
or
nature or
composition of the
composition
weird
of the
debris,
weird
whether it
debris,
is
whether
coming
it is
from the
coming from
slider,
the slider,
whether it is
whether
coming
it is
from
coming
the
from the
surface, or
surface,
whether it
or
is
whether
some
it is some
intermetallic
intermetallic
compound
compound
that you are
that
getting.
you are getting.
So for
So
that
for
you
that
can
you
do
can do
EDS.
EDS.
EDS will tell
EDS
you the
will tell you the
elemental
elemental
composition,
composition,
what all
what
elements
all
are present.
elements are present.
So
So
generally you can
generally
do
you
either
can do
EDS
either
of the
EDS
wear
of the wear
surface,
surface,
worn out
worn
surface,
out
or you
surface,
can
or
do
you
wear
can do wear
like this. You
like
can
this. You can
do worn
do
on the
worn
worn
on
out
the worn out
surface,
surface,
or you can
or you
also
can
do on the
also do
debris
on the debris
particles.
particles.
Okay,
Okay.
so that
So
will
that will
tell you the
tell you the
elemental
elemental
composition of the
composition of
surface
the
as well as
surface
the
as well
debris
as the debris
particles.
particles.
Third is
Third is
sorry, this
sorry,
so this is third.
this
So
is
fourth
third. So fourth
you can do is
you can do is
XRD.
XRD.
So
So
XRD is
XRD
nothing
is
but
nothing but
X-ray
X-ray
diffractometry.
diffractometry.
So there
So there
you can
you can
get to know
get
about
to
the
know
phase
about the phase
distribution at the
distribution at the
surface
surface,
and also at
and
the
also at the
of the weird
of the
debris.
weird debris.
As we
As
said
we
that
said that
if any
if any
intermetallics are
intermetallics
formed or
are
not,
formed or not,
if
if
any third
any
phase
third
is
phase is
coming into
coming
picture
into
or not,
picture or not,
because
because
the
the
temperature at this
temperature at this
interface
interface
may
may
lead to the
lead to the
evolution of another
evolution of
phase.
another
We
phase.
don't know,
We don't
right?
know, right?
And then
And then
suppose you are
suppose you are
conducting this
conducting this
experiment in a
experiment in a
lubricated condition.
lubricated
Suppose you
condition.
are
Suppose you are
providing some
providing some
type of fluid
type of
here.
fluid here.
So as a
So
result
as a
of that,
result of
some
that, some
elements or some
elements or some
molecules from the
molecules from
fluid
the
can
fluid can
interact with the
interact with
debris
the
and
debris and
lead to
lead
another
to another
compound,
compound,
which can get
which can get
embedded on
embedded
this
on this
worn out
worn out
surface.
surface.
So
So
those things
those
also
things
matter a
also
lot
matter a
when you
lot
are
when you are
thinking about
thinking
real
about
life
real life
applications.
applications.
So
So
suppose
suppose
the debris
the
or
debris
whatever
or whatever
material which is
material
forming,
which is not there
in the
in the
initial stages
initial
of
stages of
this
this sliding
sliding
condition. It was
condition.
not
It was
present
not
in the
present in
initial
the
stages,
initial
but
stages, but
after some
after
time that
some
has
time that has
evolved due
evolved
to
due to
the
the
interaction.
interaction,
And you are
and
seeing
you are
that
seeing that
particular
particular
phase or that
phase or that
particular
particular
element that is
element that
helping
is
you in
helping you in
improving the
improving the
in
in
reducing the
reducing the
friction
friction
between the two
between the two
surfaces. It
surfaces.
is
It is
reducing the
reducing the
coefficient of friction.
coefficient of
Then
friction. Then
you can say
you
that
can say
yes,
that
we
yes,
can
we
choose this
can choose this
particular medium
particular
or this
medium or this
particular
particular
surface coating.
surface
That
coating.
even
That
after
even after
breaking or
breaking or
degrading,
degrading, it is
sacrificing itself,
sacrificing
but it
itself,
is
but it is
leading to
leading to
reduced
a reduced
coefficient of
coefficient
friction.
of friction.
But if you see
But if
that
you see
due
that
to this
due to this
degradation,
degradation,
some
some
unwanted
unwanted
phenomena is
phenomena
occurring,
is occurring, like
some corrosion
some
is
corrosion
occurring
is
at the
occurring
surface.
at the
So
surface. So
this
this
surface after
surface after
this is your
this is your
surface before
surface
wear, and
before
this is
wear,
your
and this is
surface
your
after
surface
wear.
after wear.
So if I
So
am
if I'm
denoting it as A
denoting
and
it as
this one
A
as
and this
B,
one as B,
then surface
then
A
surface
and
A
surface
and
B are
surface B
having
are
different
having
corrosion
different corrosion
resistance.
resistance.
Generally,
Generally,
surface A
surface
is
A is
like we can
like
say
we can
that,
say
but
that, but
it can have
it can
higher
have
corrosion
higher corrosion
resistance
resistance
than
than
surface B,
surface B,
or it can be
or
the
it
other
can be
way
the
around
other way
also.
around also.
Like the
Like the
if some
if
oxide
some
phase is
oxide phase
forming
is
at B
forming
and it
at B
is
and it is
forming a
forming a
passive layer
passive layer
on top,
on
then
top,
its
then its
corrosion
corrosion
resistance may
resistance
increase.
may increase.
You never know
You
that.
never know that.
So as a
So
result,
as a
we
result,
can see a
we can
lot
see
of
a lot of
synergistic
synergistic
parameters or
parameters or
happenings are
happenings are
involved here.
involved here.
As a result
As a
of that,
result of that,
we are
we are
interested in so
interested in
many
so many
characterizations
characterizations
after the wear.
after the wear.
So
So
you can see
you
that
can
just
see that
after
just after
the material
the
has
material has
degraded,
degraded,
we are throwing
we are
it off.
throwing it off.
But
But
still, to
still, to
understand the
understand the
degradation phenomena,
degradation
we can
phenomena,
do
we
so
can do
much of
so much
things
of
with the
things with the
discarded
discarded
components.
components.
So yeah,
So yeah,
that was
that
the
was the
purpose of this
purpose of
entire
this entire
discussion. You can
discussion.
say
You can say
that.
that
Okay.
okay.
So
So
coming to the
coming
next
to the
question,
next question,
the wear
the wear
suffered by
suffered by
structural
structural
components
components which are
experiencing
experiencing hypersonic rate of fluid
interaction is called
interaction is called
impingement
impingement
erosion,
erosion,
fatigue wear,
fetting wear,
low stress
low
wear, and
stress wear,
abrasive
and
wear
abrasive
or
wear
abrasive
or
wear.
abrasive wear.
Impingement erosion.
Yes.
Yes.
So there
So there
um,
um,
some
some
particles or
particles
even
or even
fluid
fluid
molecules
molecules say,
that will
that
impinge
will
on the
impinge on
surface
the
at
surface at
with high
with high
momentum, and
momentum,
as a
and as
result
a
of
result
this
of this
high energy,
high
it will
energy, it will
cause
cause
deformation on the
deformation on the
surface,
surface,
and due to
and
that
due to that
plastic
plastic
deformation happens,
deformation
some
happens,
crack
some crack
initiates and it
initiates and it
propagates along
propagates along
some random
some random
directions,
directions,
and as a
and
result
as a
of that,
result of that,
the wear
wear
happens.
happens.
Achha,
Achha,
every time I am
every time
telling
I'm
wear
telling wear
happens,
happens,
rate of wear.
rate
So
of
what
wear.
is
So what is
exactly wear?
exactly wear?
There is
There
a
is a
definition in the
definition
book,
in the book,
in books,
in books,
but
but
like how do
like
you
how do you
understand wear?
understand wear?
So the loss of material.
Is it
Is it
always the loss
always the
of
loss of
material?
material?
Okay, so
Okay, so
okay, as you're
okay,
saying,
as
it is
you're
the
saying, it
loss
is
of
the loss
material,
of
but
material, but
it can be the
it can
loss
be
of
the
shape
loss of
also,
shape also,
right?
right?
So from
So
the
from the
surface,
surface,
suppose this is
suppose
your
this is
initial
your
surface,
initial
you
surface,
haven't
you
lost any
haven't lost
material,
any
but your
material,
shape
but your
changed
shape
like this.
changed like this.
That is also
That
a
is
type
also
of
a
wear.
type of wear.
So
So
you have heard of
you have heard of
brenneling, right?
brenneling, right?
So
So
brenneling is
brenneling
also
is also
similar to
similar
this.
to this.
And apart
And
from this,
apart from
another
this,
thing,
another thing,
say
say
your
your
worn out
worn
material,
out
like
material, like
we are saying
we
that
are
loss
saying
of
that loss
material. So
of
the
material. So
material
the
is lost
material is
from the
lost from the
surface, then
surface, then
it
it
may
may
get
get
deposited on the
deposited on
surface
the
at a
surface at
different
a
area,
different area,
or it
or it
can be
can be
deposited on the
deposited on the
others
other
mating
mating
surface at
surface at
some other
some other
areas.
areas.
Suppose two
Suppose
mating
two mating
surfaces are there.
surfaces are there.
In that
In
case,
that
some
case,
material
some
can
material can
get
get
removed from
removed
the
from
surface
the
and
surface
get
and get
deposited here.
deposited here.
Okay, so
Okay,
in
so
that
in
case,
that case,
won't you say
won't
that
you
the
say that the
functionality of this
functionality of this
component is
component is
also
also
degraded?
degraded?
I mean,
I mean, from say foreign material, some particles are getting embedded on my surface, on this component surface or the surface that is concerned.
So in
So
that case
in
also
that
we
case,
will
also
say
we will
that
say that
degradation is
degradation
happening,
is happening,
right?
right?
So wear
So
can be
wear can be
manifested in
manifested
different
in
forms,
different forms,
not
not
only loss of
only loss of
material. It can
material.
be
It can be
loss of
loss
shape,
of shape,
loss of
loss of
functionality or
functionality or
performance,
performance,
and
and
yeah,
yeah,
more
more
obviously the loss
obviously
of
the loss of
material.
material.
Okay,
Okay,
rate of
rate of
increase in
increase
crack
in
length
crack
with
length with
number of
number of
cycles.
cycles.
So
So
n is the
n
number
is
of
the number
cycles
of
to
cycles
failure,
to failure,
and L
and
is the
L is
crack
the
length.
crack length.
So
So
in this,
in this,
it is
it is
dependent on the
dependent
stress
on the stress
amplitude,
amplitude,
as you may
as
recall.
you may
So
recall.
does it
So does it
increase with the
increase
increase
with the
in stress
increase in
amplitude,
stress
or it
amplitude, or it
decreases with
decreases
increase
with
in stress
increase in
amplitude?
stress amplitude?
So as you
So
are
as you are
increasing the stress
increasing the stress
amplitude,
amplitude,
what happens
what
to this
happens to this
parameter? It
parameter? It
increases or
increases or
decreases
decreases
at higher
at
stress
higher stress
values
values
or at higher
or at
stress
higher stress
amplitudes?
amplitude.
Obviously, this will
Obviously, this will
increase.
increase.
So it
So it
increases with
increases with
increase in
increase in
stress amplitude.
stress amplitude.
It is
It is
independent of the
independent of
material
the material
properties?
properties?
No.
No.
It is
It
lower
is
for
lower for
materials
materials
possessing higher
possessing
Young's
higher
modulus.
Young's
Is this
modulus. Is
correct
this
or
correct or
incorrect?
incorrect?
What about
What
option
about option
C?
C?
So you have a
You have a
mathematical
mathematical
formulation for
formulation
this,
for
right?
this, right?
What is it?
What is it?
So what is the
What is the
mathematical
mathematical
formulation?
formulation?
Somewhat
Somewhat
like
like
this,
this,
right?
right?
What is
What
this?
is this?
What is this
What is
entire
this
term
entire
called?
term called?
Yeah. What do we call?
What do we call?
What is this
What is this
term?
term?
This is also
This
known
is
as
also
stress
known as stress
intensity factor,
intensity
right?
factor, right?
Which we call as
We call
delta
as
K.
delta K.
And
And
to
to
incorporate the
incorporate
material
the material
properties, we
properties, we
also multiply
also
it with
multiply
another
it with another
constant, say A.
constant, say, or
So this M
so this
and
M
A
and A
are the
are
material
the material
properties.
properties.
The
The
stress
stress
intensity
intensity
factor,
factor,
it's
it's
dependent on E,
dependent on E,
right?
right?
So
So
this E is
this E is
basically your
basically your
Young's
Young's
modulus,
modulus,
and
and
as we
as
increase
we
the
increase
Young's
the Young's
modulus,
modulus,
this
this
rate will
rate will
also go
also
up.
go up.
Any
Any
confusion
confusion
regarding this?
regarding this?
So depending
So
on the
depending
stress
on the stress
intensity factor, you
intensity
have
factor,
three
you have three
stages of
stages of
erosion, right? In
erosion,
the
right? In
stage
the
one,
stage one,
the crack
the
length,
crack length,
like
it is not
significant. In
significant.
stage
In
two, it
stage
will be
two, it will be
linear.
linear.
So we are
So
drawing
we are
in log
drawing in log
scales.
scales.
This is stage
This is
one,
stage
this
one.
is
This
stage
is
two, and
stage
this is
two, and
stage
this is
three.
stage three.
In stage
In
3, it
stage
will
three, it will
abruptly
abruptly
increase.
increase.
Okay,
Okay.
coming to the
Coming
next
to the
question.
next question.
In
In
abrasive wear,
abrasive
the
wear,
wear rate
the wear rate
increases with
increases with
increase in
increase in
it
it
increases with
increases
increase
with
in the
increase in the
sharpness and
sharpness
hardness
and
of the
hardness of
abrade.
the abrade.
Other
Other
surfaces
surfaces
like
like
increase in
increase
hardness
in
of
hardness
the
of the
substrate surface.
substrate
That's
surface.
wrong,
That's wrong,
obviously.
obviously.
Decrease in
Decrease
sliding
in
distance. So
sliding
we already
distance. We already
discussed if we
discussed
increase
if
the
we increase
sliding
the
distance,
sliding distance,
abrasive wear will
abrasive wear will
increase.
increase.
Decrease in normal
Decrease in
load. So
normal
these
load.
three
So these
are
three
obviously
are
wrong.
obviously wrong.
Rate of
Rate of
erosion wear
erosion wear
increases with
increases
increase
with
in
increase in
abrasive
abrasive
impingement
impingement
angle for
angle
all
for all
materials.
materials.
Decreases with
Decreases
increase
with
in
increase in
abrasive
abrasive
impingement angle
impingement
for all
angle for all
materials
materials
is
is
independent of
independent of
abrasive
abrasive
impingement angle.
impingement angle.
Is
Is
maximum at an
maximum at an
optimum value
optimum
for
value for
ceramics and then
ceramics and then
decreases,
decreases,
or none of
or
this.
none of them.
So what is the
What
correct
is the
option
correct
here?
option here?
What will be the
What will
correct
be the
option
correct
in this
option in
case
this case?
with this
With
particular
this
question?
particular question.
Yeah.
Yeah.
So I'm
So
expecting
I'm
some
expecting
answers
some
from you
answers
also.
from you also.
So
So
what is the
what
wear
is the wear
mechanism in case
mechanism
of
in case of
erosion wear?
erosion wear?
You have
You
some
have some
particles
particles
which
which
impinges on the
impinges on the
surface with high
surface with high
momentum
momentum
or high
or high
velocity,
velocity,
and it
and
chips
it
away
chips away
some material
some
from the
material from the
surface. So
surface.
some
So some
plastic
plastic
deformation takes
deformation
place,
takes place,
which
which
causes
causes
microfracture
microfracture
and micro
and micro
cracks,
cracks,
like micro
like
cracks
micro
and then
cracks and then
microfracture,
microfracture,
and as a
and
result
as a
of
result of
which
which
chip out
chip out
happens.
happens.
So that
So
is
that is
like the
like
basic
the
of
basic of
erosion wear.
erosion wear.
So
So
generally it is
generally it
at
is at
like high
like high
velocity, I would say.
velocity, I would say.
Momentum,
Momentum,
yeah,
yeah,
obviously
obviously velocity is high, momentum
also
will
be high.
also be high.
So
So
this is my
this is my
surface and this is
surface
my
and this is my
abrasive particle.
abrasive particle.
So it is
So
saying
it is
that
saying that
if this
if
angle
this angle
theta, say,
theta, say,
from the
from
surface
the
to
surface
the
to the
velocity
velocity
direction or
direction
the
or the
impingement
impingement
direction.
direction.
So if
So if
theta is
theta
lower,
is lower,
what happens
what
if
happens
theta
if
is lower?
theta is lower?
So if you
So if you
concentrate on
concentrate
this
on this
particular point
particular point
where the
where the
impingement is
impingement
happening,
is happening,
say the
the
particle is
particle
coming
is
here
coming here
along this line
along this line
for one
for
case,
one case,
and in a
and in
second
a second
case
case
the
the
particle is
particle
coming
is
along
coming
this line.
along this line,
It's theta 1
theta 1,
and this is
and
theta
this is
2.
theta 2.
In which
In
case do
which
you
case do you
expect a
expect
higher
a higher
energy
energy
of
of
impingement
impingement
or higher
or higher
deformation of the
deformation of
material?
the material?
Let's not talk
Let's
about
not talk about
deformation, but in
deformation,
which
but in which
case do
case
you think
do you
the
think the
mm,
mm,
like more
like more
energy will be
energy will
delivered
be
onto the
delivered onto the
surface by the
surface by
abrade?
the abradant?
In case
In
1 or in
case
case
1 or
2?
in case 2?
So if the
If
angle
the
is
angle is
increasing,
increasing,
you are seeing
you are
that
seeing
the
that
y
the
velocity,
the y component of velocity,
the rate
the
of
rate of
decrease in y
decrease in y
component of
component of
velocity is
velocity
higher
is higher
compared to rate
compared
of
to rate of
decrease in x
decrease in x
component of
component
velocity.
of velocity.
And because
And
of
because
that,
of that,
what happens?
what happens?
The force
The
that is
force that
delivered.
is
So force
delivered.
is
So
nothing
force
but
is
the
nothing
change
but the
in
change
momentum.
in momentum.
Momentum is
Momentum is
also like
also
mass into
like mass into
velocity. So
velocity. So
along the
along
y
the y
direction, the change
direction, the
in
change in
momentum will be
momentum will be
higher.
higher.
So that change
So
in
that change
momentum
in
higher
momentum
means the
higher means
force
the force
imparted by
imparted
this
by
by this
by this
impinging
impinging
abrasion will be
abrasion
higher.
will be higher.
So
So
F2 will
F2 will
be higher
be
than
higher than
F1.
F1.
So you need
You
to
need to
understand that
understand that for different, so for all materials, first of all,
we can't
we
say
can't say
that
that
it will
it will
absolutely increase
absolutely
or
increase or
absolutely
absolutely
decrease
decrease
with the
with
increase
the
or
increase
decrease
or
in the
decrease in the
impingement angle.
impingement
We can't
angle.
say
We
that.
can't say that.
Why?
Why?
Because
Because
materials
materials
offer
offer
different type of
different type of
resistance to
resistance
this
to this
type of
type of
deformation
deformation
or to
or
this
to this
impingement action,
impingement action,
right?
right?
So if
So
we
if
talk
we
about
talk
some
about
soft
some soft
metals or
metals
like
or
some
like
soft
some soft
material,
material,
so they will,
so they will
like
like
when you are impinging at a high
impinging at a high
velocity through
velocity
here,
through here,
this
this
particle,
particle,
if it is a
if it
tough
is a
material,
tough
then it
material,
will
then
try
it
to
will try
bounce
to
off,
bounce off,
or it
or
if
it
it is
if it
like
is like
if it is
if
able
it is
to
able to
if it is a
if it
soft
is a
material,
soft
then
material,
it
then
will
it will
like
like
impregnate into
impregnate
this
into this
particular
particular
surface. So you
surface.
can see
You
that
can see
after
that after
jet
jet
after
sorry, after
sandblasting or
sandblasting
after
or after
grid
grid
blasting,
blasting,
there will be
there will
some
be some
particles
particles on
on the
the
surface.
surface.
So that is
So
due
that is
to
due to
like some sand
like some
particles
sand
or the
particles or the
foreign
foreign
abrasive
abrasive
particles, which will
particles,
be
which will be
embedded on the
embedded on
surface.
the
So
surface.
due to
So
this
due to this
impregnation,
impregnation,
that happens
that
at
happens at
higher
higher
angles,
angles,
like say
like say
theta
theta
2 or
2 or
which closes
which
90
closes
degree.
90
So
degree. So
the
the
closer to 90
closer to
degree. So
90
that
degree. So that
angles would lead
angles would
to
lead to
a higher
a higher
impregnation of these
impregnation of these
particles. So
particles.
why that
So why
happens?
that happens?
Because
Because
you're not
you're not
allowing it to
allowing it to
bounce back
bounce
or
back or
move to
move to
like this
like this
x component
x
of
component of
velocity will be
velocity will
less.
be less.
So that's
So
why
that's why
this
this
entire change
entire
in
change in
momentum will be
momentum will
happening
be
only
happening
in
only
y
in
direction.
y direction.
So if your
So if
material
your
is
material
soft
is soft
or
or
ductile, there are
ductile, there are
chances of
chances
this
of this
you can say
you can say
binneling effect, or
binneling
you can
effect, or you
say
can say
embedding of
embedding of
particles
particles
depending on the
depending on the
velocity that will
velocity
happen.
that will happen.
So that's
So
why the
that's why the
material removal
material
will be
removal will
less,
be
less material
less
removal
material
for
removal
softer
for softer
materials.
materials.
You can see
You can see
microfracture
microfracture
happening from here,
happening from here,
but
but
the wear
the
rate
wear
or the
rate or
erosion
the
rate
erosion
won't
rate
be much
won't be
high
much high
because these
because these
particles are
particles
getting
are
embedded
getting
on the
embedded on the
surface.
surface.
This happens
This
in case
happens
of
in case
softer
of materials like
metals, most of
metals.
the
Most
metals
of the
we can
metals
say.
we can say.
However, if you
However,
go
if you
for
go for
ceramics, which are
ceramics,
hard
which
as
are
well as
hard as well as
tough,
tough,
so in
so
that
in
case,
that
what
case, what
happens?
happens?
There, the
There,
failure
the failure
mechanism is
mechanism
different.
is
So
different. So
as
as
you're
you're
increasing the
increasing the
angle
angle
theta
theta
from a
from
lower
a lower
value to a
value
higher
to a
value. So
higher
this
value.
is
So this is
say
say
theta 1
theta
and this is
1 and this
theta
is
2.
theta 2.
So at
So at
theta 2,
theta 2,
since the
since the
material may
material may
fracture by
fracture
brittle
by
fracture
brittle fracture
mechanism,
mechanism,
so
so
here
here
as I said
as I
that for
said that for
ceramics
ceramics
at
at
higher
higher
value of
value
angles,
of
the
angles, the
failure will be
failure will
higher.
be higher.
Material failure,
Material
like the
failure,
chip
like
off
the
will
chip
be
off
higher.
will be higher.
So this
So this
abrasive will come
abrasive will
here
come
and
here
bounce
and
back,
bounce back
since it is a
since it
tough
is a
material,
tough material,
and due to
and
that
due to that
change in
change
energy
in
that
energy that
sorry, the change in
sorry, the change
momentum,
in
the force
momentum, the
that is
force that
delivered,
is delivered,
if that
if
force is
that force
beyond,
is beyond,
like that force
like
will
that
be
force will be
imposing a stress
imposing a
here.
stress
So
here.
if that
So if
stress
that
is
stress
beyond
is
the
beyond the
yield stress,
yield
then
stress,
it will
then it
undergo
will undergo
deformation, and
deformation and
slowly fracture
slowly
will take
fracture will
place.
take place.
And
And
yeah,
yeah,
so that
so
is
that is
the
the
mechanism here. So
mechanism
in
here.
case
So
of
in case of
ceramics,
ceramics,
a
a
higher
higher
theta
theta
will lead
will
to
lead to
higher
higher
erosion rate,
erosion rate
because the
because the
abrasives will come
abrasives will
here,
come
hit
here,
it,
hit
and
it, and
bounce back.
bounce back.
It won't
It
get
won't get
embedded onto the
embedded onto the
surface,
surface
because these are
because these
tough.
are tough.
Ceramics are hard
Ceramics
as
are
well as
hard as
tough.
well as tough.
So
So
and that's why
and
a
that's why
higher
a higher
value of theta will
will
cause a higher
cause a
erosion
higher
rate.
erosion rate.
Whereas in case
Whereas
of
in case of
metals or
metals
any
or
soft
any soft
material,
material,
this
this
embedment
embedment
of the
of the
abradant will take
abradant will
place,
take
and as
place,
a
and
result
as a
of
result
which
of which
your
your
material
material
removal will be
removal
less,
will be
or
less,
we can
or
say that
we
the
can say that the
erosion rate
erosion
will be
rate
less
will be less
at higher
at
value
higher
of
value of
this
this
impingement angle.
impingement angle.
So in
So
that,
in that,
on the
for
contrary,
metals,
for
if you
metals,
see,
if you are
if you are
reducing the angle,
reducing the angle,
suppose
suppose you're impinging it at an angle of theta 1, which is less than
this angle,
this
say.
angle, say.
So what
So
happens
what
here?
happens here?
Plowing action
Plowing
takes
action
place
takes
over
place
here.
over here.
So plowing
So
means
plowing
this
means this abrasive will
make a
make
track
a
on this,
track on
just
this,
as
just as
on the
on the
fields the
fields the
farmers plow.
farmers
No?
plow.
So
No,
like
so
that,
like that,
the
the
abrasives, if you are
abrasives, if you are
giving the
giving the
higher
a
x
higher x
component
component
velocity by
velocity by
reducing the
reducing
angle,
the angle,
then it will
then it will
plow
plow
over a longer
over a longer
distance.
distance.
So
So
this is the
this is
plowing
the
action.
plowing action.
This will be
This
more
will be more
pronounced in case
pronounced
of
in case of
metals.
metals.
Or softer
Or softer
surfaces, and
surfaces, and
as a result
as a
of this,
result of this,
the wear
the
rate
wear
will
rate will
increase
increase
due to the
due to
plowing
the
action.
plowing action.
So as a
So
result,
as a
we can
result, we
say
can
that
say
for
that for
metals,
metals,
as we
as
increase
we
the
increase the
again, if
again,
the
if
theta
the
one
theta
is
one is
much
much
lower than
lower than
particular
particular
value, say
value,
optimum
say
value,
optimum value,
then there will be
then
no
there will be
plowing
no
action
plowing
at all,
action at all,
because in the
because
y
in the y
direction
direction
the force
the
will,
force
you
will
need
you need
like
like
components both in
components
the
both
x
in
and the
the
y
x and the y
directions. Like
directions. Like
there should
there
be
should be
this
this
abrasive particle
abrasive
should
particle should
be impinged
be
on the
impinged on
surface
the
as a
surface as a
and at the
and
same
at
time
the
it should
same time
also
it
be
should also
grazed
be
on the
grazed on
surface.
the surface.
Only then you will
Only
get
then
the
you will
plowing
get the
action.
plowing action.
But at
But
lower
at
values
lower
of
values
theta
of
1,
theta 1,
this
this
component is
component
so
is
low
so
that it is
low that
not
it is
able
not
to
able to
indent on the
indent
surface,
on
or
the
it is
surface, or
not
it is
able to
not able to
make an
make an
indentation on the
indentation on
surface.
the
So there
surface.
will be
So
no
there will be
plowing
no
action,
plowing
and
action,
the
and
wear will
the
be
wear
less.
will be less.
So
So
that's why
that's why
for
for
metals,
metals,
if you
if
recall
you recall
correctly,
correctly,
this is the
this is the
so this is
so this
wear
is
rate or
wear rate
erosion
or
rate,
erosion
and
rate,
this is
and
the
this
value
is
of
the value
theta.
of theta.
This is for
This is for
metals.
metals.
So
So
for a given
for a
value
given
of
value
theta,
of theta,
the
the
wear
wear
sorry for
sorry for
if you
if
increase
you
the value
increase
of
the
theta
value of theta
from
from
0 degrees
0
slowly,
degrees slowly,
then the wear
then
rate
the
will
wear
increase
rate will
up to
increase up to
value.
a value.
This
This
can be
can
in the
be
range
in
of
the range
15
of
to
15 to
30 degrees,
30 degrees,
and after
and
that
after
value,
that
this
value, this
wear rate
wear
again
rate again
reduces,
reduces,
or I would
or
say
I would
erosion
say
rate.
erosion rate,
It again
it again
reduces.
reduces.
And why it
And why
reduces?
it
I
reduces?
already
I
said,
already
because
said,
of
because of
embedment or
embedment or
impregnation of the
impregnation of the
abrasive particles
abrasive
on the
particles on the
surface.
surface.
So that would
So that would
arrest the
arrest the
crack
crack
propagation.
propagation.
However, on
However,
the
on the
contrary, for
contrary, for
ceramics, if we
ceramics,
see
if
that
we
it,
see
it will
that it will
gradually increase,
gradually
and
increase, and
at higher
at
values
higher
of
values
theta,
of
it will
theta, it will
lead to
lead
higher
to higher
erosion rate.
erosion rate.
So why was
So
this
why was this
discussion
discussion
important?
important?
Because
Because
see, from
see,
erosion
from
point
erosion
of view,
point
or
of
from
view,
the
or
point
from the
of view of
point
the
of view of the
course of this
course of
particular
this particular
subject,
subject,
you can see
you
that
can see that
it plays a
it plays a
negative
negative
role. Like
role.
we
Like
shouldn't
we shouldn't
increase the
increase
value of
the value
theta
of
for
theta for
ceramics, or
ceramics, or
like this
like this
particular
particular
value of
value
theta
of
is
theta is
detrimental for the
detrimental for the
surface.
surface.
So that
So
was the
that
summary
was the
for this
summary for
discussion.
this
But
discussion. But
there are
there are
scenarios
scenarios
where
where
you would
you would
try to
try
achieve
to
this
achieve this
particular theta,
particular theta,
arrive at
arrive
this
at
particular
this
theta
particular
to
theta to
have more
have
material
more
removal.
material removal.
Suppose
Suppose
you are doing
you are
some
doing some
abrasive jet
abrasive jet
machining.
machining.
So with the
So
help
with the
of
help of
some
some
abrasive
abrasive
particles, you are trying
particles,
to
you are
machine
trying
a
to machine
feature
a
on a
feature on
surface,
a
say a
surface, say
channel
a
or a
channel
hole.
or a hole.
So on
So
glass
on glass
surfaces or
surfaces
on
or
brittle
on brittle
surfaces,
surfaces,
generally we do
generally we do
abrasive jet
abrasive
machining.
jet machining.
On ductile
On ductile
surfaces, we do
surfaces, we do
abrasive water
abrasive
jet
water
machining
jet
or
machining or
water jet
water
machining.
jet machining.
So that
So that
there also the
there also
material
the material
removal
removal
is by
is
the
by
action
the
of
action of
erosion wear,
erosion wear,
and the
and
same
the same
phenomenon occurs
phenomenon
there.
occurs there.
So there we
There
try
we
to
try
vouch
to
for
vouch for
this
this
particular value of
particular value
theta.
of theta.
While in case
While
of
in case
erosion,
of
we
erosion,
design
we
the
design
system
the
in such a
system in
way
such a
that
way that
this
this particular
theta or this
theta or
particular
this
angle of
particular angle of
impingement is
impingement is
avoided
avoided
in case of
in case
erosion.
of erosion.
Okay,
Okay.
so coming to the
So coming
next
to the
question,
next question,
which of
which
the
of the
following wear
following
is
wear is
usually
usually
experienced by
experienced
hard
by hard
chromium plated
chromium plated
camshaft?
camshaft?
Spalling,
Spalling,
High
High
stress
stress
abrasion,
abrasion,
impact wear or
impact wear or
Brinelli?
Brinelli?
Yeah, so
Yeah. So
just tell me, like
just
in
tell me, like in
camshaft,
camshaft,
what type of
what type
load
of
do you
load do
expect?
you expect?
Hello?
Hello.
Is anyone
Is
there?
anyone there?
Just to
Just to
confirm.
confirm.
I mean,
I mean,
yeah.
Yes, sir. Yes.
Okay, okay.
okay,
So,
okay. So
yeah, what
yeah,
would be your
what would
answer
be
to
your
this?
answer to this?
First,
First,
identify the
identify
load
the
that is
load
acting
that is
on a
acting on a
camshaft.
camshaft.
It is an
It is an
automotive
automotive
component
component
used in
used in
engines.
engines.
So,
So
these
these
components are
components are
generally
generally
subjected to
subjected
fatigue
to
loading
fatigue loading
or
or
fluctuating loads.
fluctuating loads.
From
From
tensile to
tensile to
like
like
generally it's a
generally it's a
torsional
torsional
bending type
bending
of
type
load.
of load.
Like it is
Like it is
rotating
rotating
under a bending
under a
axle.
bending axle.
Okay,
Okay.
so
So
I'm just
I'm just
showing one.
showing one.
So it is
So it is
rotating
rotating
under the
under
action
the
of
action of
some load.
some load.
Okay,
Okay.
this is just
This
a
is just a
representation.
representation.
So
So
this is
this is like
a fatigue
a
loading
fatigue loading
condition. So
condition. So
in that
in
case,
that case,
which type of
which type of
wear do you
wear do you
generally
generally
expect here?
expect here?
Sir, impact wear.
In
In
impact wear, you
impact
should
wear,
be
you should
having
be
some
having some
impacting
impacting
body over
body
here,
over here,
right, which will
right, which
come
will come
and
and
hit this
hit
surface
this
at high
surface at high
velocity
velocity
or at
or at
like a high
like a high
mass of
mass of
particle or
particle
something
or
will
something will
impact on this
impact on this
surface. But
surface.
that is
But
not
that is
happening
not
here, right?
happening here, right?
You're not
You're not
subjecting it to
subjecting it
an
to an
impact load.
impact load.
There's no
There's no
impact load here.
impact load
Impact
here.
load
Impact
is
load is
uh,
uh,
like
like
this will be
this
very
will be
high.
very high.
Like
Like
over a
over
small
a
period
small
of
period
time,
of time,
you are
you are
giving a
giving
large
a
load,
large load,
a large
a
amount
large
of
amount
force.
of force.
So this is
So
not
this is
the
not the
scenario here.
scenario here.
Here you are
Here you
seeing
are seeing
moderate loading
moderate loading
condition,
condition,
but
but
that is
that is
fluctuating
fluctuating
or
or
cyclic loading.
cyclic loading.
So you're seeing
You're seeing
cyclic loading
cyclic
here.
loading here.
So
So
brinelling,
brinelling,
see
see
impact wear,
impact wear, brinelling wear,
high stress
high stress
abrasion.
abrasion.
Here,
Here,
in all of
in
these
all
three
of these
cases, you
three
have a
cases, you have a
second body
second
which is
body which
coming
is
and
coming
attacking
and
the
attacking the
surface,
surface,
right?
right?
Hello.
Hello.
Yes,
Yeah.
sir.
Yes.
Mhm.
Yes.
Yes, yes.
So yeah,
So
in
yeah, and in
abrasion you see
abrasion,
that
you see that
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 abrasion it is
abrasion it is
grazing on the
grazing on
surface,
the
and as a
surface, and
result
as a
of that,
result
wear
of
is
that, wear
happening.
is happening.
And yeah, the
And yeah,
load
the
which
load
is acting
which is
on
acting
the
on
particle
the
will be
particle will
higher
be
than in
higher
case
than
of
in
low
case
stress
of low
abrasion.
stress
As a
abrasion.
result,
As
the
a result, the
mm, some
uh,
plastic
some plastic
deformation is
deformation
happening,
is happening,
and then
and then
microcracks are
microcracks are
generating, and
generating, and
as a result,
as a
the
result,
wear is
the
happening.
wear is happening.
In case of
In case of
impact wear,
impact wear,
you see
you
some
see some
particle having
particle
mass.
having
It is
mass. It is
impacting on the
impacting on
surface
the
at a high
surface at a high
velocity and
velocity
for a
and
very
for a
less
very
amount
less
of time.
amount of time.
As a result
As a
of that,
result
it
of
will
that, it
indent
will
on the
indent on the
surface. It
surface.
will
It
cause,
will cause,
first of all,
first of all,
plastic
plastic
deformation. It will
deformation.
indent
It
on
will
the
indent
surface,
on the
and from
surface,
here,
and from here,
subsurface cracks will
subsurface
be
cracks will
generated.
be generated.
In case of
In case of
brinelling, again
brinelling,
same,
again
like
same, like
under a
under a
constant load,
constant load,
you will
you will
press a
press a
particular
particular
particle on the
particle on the
surface.
surface.
So as a
So
result
as a
of
result
this,
of this,
some plastic
some plastic
deformation will take
deformation will
place
take place
localized to this
localized to this
particular region,
particular region,
and the
and
shape
the
will
shape
change.
will change.
In none of the
In none of the
cases we
cases we
saw that
saw that
a
a
cyclic loading
cyclic
condition
loading
is there.
condition is there.
However, in case
However,
of
in case of
spalling,
spalling,
what we see
what we
that
see that
it is shown
it
here
is
that
shown here that
it is being
it is
mentioned
being
here. It is a
mentioned here. It
hard
is a hard
chromium plated
chromium
camshaft.
plated camshaft.
Okay.
Okay.
Generally, it is
Generally,
done
it is
through
done through
electroplating.
electroplating.
So
So
the
the
we can say
we
that the
can say that
plating
the plating
that
that
the
the
interfacial strength
interfacial strength
of the
of the
uh,
uh,
component of
component
the
of
coating
the
and the
coating and
component
the
of this
component of this
chromium
chromium
coating and the
coating and the
substrate
substrate
steel,
steel,
that
that
interfacial
interfacial
strength will
strength will
reduce
reduce
with the number
with
of
the number of
cycles,
cycles,
because
because
say this is
say this
your
is your
surface
surface
and
and
this is your
this is your
coating,
coating,
right?
right?
So under
So
this
under
loading
this loading
condition,
condition,
this
this
is being
is being
subjected to
subjected
a
to a
tensile load
tensile load
followed by a
followed by a
compressive load.
compressive load.
Again tensile
Again
load
tensile
followed
load
by a
followed by a
compressive load.
compressive load.
So it's better
So
to
it's
show
better to
like
show
this.
like this,
Like
like
this is
this is
half cycle
half cycle
and
and
this is the
this is
next half
the next
cycle.
half cycle.
So as a
So
result
as a
of this,
result of this,
you can see
you
that
can see
the
that
failure
the
may
failure
occur
may occur
at the
at the
interface,
interface,
and
and
there will be
there will be
cracks on the,
cracks on the,
like
like
if you see
if
on
you see on
from here,
from here,
there will be
there will
failure
be
between
failure
these two
between these two
coating and the
coating and the
substrate,
substrate,
and
and
also
also
in the
in
coating
the coating
due to
due
this
to this
particular action.
particular action.
Like first
Like
it
first
will
it
initiate
will initiate
at this surface,
at this
because it
surface,
will try
because
to
it will try
slide
to
onto
slide
each other,
onto each other,
because the
because the
properties of the
properties of the
coating, the
coating, the
interface and
interface
the
and the
substrate are
substrate
different,
are different,
right? They are
right?
having
They are
different
having different
strengths.
strengths.
So as a
So
result,
as a result, generally the
at the
at the
interface the strength
interface the
is much
strength is
lower
much lower
compared to
compared
the
to
coating
at the
and the
coating and
substrate.
at the
That's why
substrate.
it will
That's why
fail
it will
first.
fail first.
So
So
spalling is
spalling is
generally
generally
observed in
observed
such
in
type of
such type of
loading
loading
conditions.
conditions.
You can also
You can
see
also
this,
see
like
this, like
if you
if you
look at
look at
the
the
axle of
axle of
any rotating
any rotating
component
component
which is
which
being
is
eroded
being
for
eroded for
which
which
is being
say is
coated,
being
and it
coated,
is
and it is
subjected to a
subjected to
cyclic
a
loading
cyclic
over a
loading over
longer
a longer
period of time.
period of time,
Then some
then
scale
some
type of
scale
things
type
are
of
coming
things are
up from
coming
the
up from
surface.
the surface.
Some like the
Some like
material
the
is,
material is
or the
or
coating
the
is
coating
getting
is getting
removed in the
removed
form
in the
of
form of
scales.
scales.
So that is
So
what
that
we
is
call
what we call
spalling. Like
spalling. Like
if
if
this is your
this is your
surface, no,
surface,
after
no, after
spalling,
spalling,
say
say
this part will
this
be
part
gone
will be gone
in between.
in between.
So you will
So you
see
will see
that the
that the
surface beneath it
surface
is being
beneath it is being
exposed.
exposed.
And as this
And
is
as this
happening,
is happening,
these are
these are
regions of
regions of
high
high
energy.
energy.
So from
So
here
from
again,
here
crack will
again, crack
propagate,
will propagate,
like
like
across the
across the
interface.
interface.
So crack
So
will again
crack will
initiate
again
in
initiate
these
in these
directions under
directions under
these loading
this loading
conditions.
condition.
So spalling
So
is the
spalling
correct
is the
option.
correct option.
Okay, so this is
Okay,
the
so this
last
is the
question
last
for
question for
today. What
today.
is the
What is the
difference in wear
difference in wear
mechanism,
mechanism,
abrasive wear and
abrasive wear and
erosion wear?
erosion wear?
We have
We
already
have already
discussed
discussed
multiple
multiple
times
times
in
in
the previous
the
question.
previous
So
question. So
yeah, I
yeah, I
want an answer
want an
from
answer
you.
from you.
Like
Like
what
what
difference can you
difference can you
suggest
suggest
in between the
in
wear
between the wear
mechanism of
mechanism of
abrasive wear and
abrasive
that of
wear and that of
erosion wear?
erosion wear?
So as
So as
the term
the term
suggests,
suggests,
this is
this is
happening due to
happening due to
abrasion,
abrasion,
and this is
and this
happening
is
due to
happening due
erosion.
to erosion.
So
So
apart from
apart
this,
from
I
this,
want
I want
the answers,
the
like
answers. Like
what is the
what is the
mechanism of wear?
mechanism of wear?
Yeah.
Yeah.
What will be your
What will
answer
be your
to
answer
this?
to this?
You can
You can
expect this
expect
small
this
small
small
questions in
questions
your
in
exam
your
also.
exam also.
If you are
Like if you are
if you're
taking,
writing
if
the
you're
exam
writing the exam
on this
on
particular
this particular
course.
course.
So in
So in
abrasive wear,
abrasive
you
wear,
have
you have
generally you have a
generally you have a
constant
constant
contact
contact
between
between
the
the
meeting
meeting
surfaces,
surfaces,
or I
or
won't say
I
meeting
won't say
surface,
meeting
rather
surface, rather
the two
the two
surfaces
surfaces
of the
of the
abradant and
abradant and
the concerned
the
surface
concerned
that you're
surface that you're
speaking of. So there
speaking of.
will
So
be
there will be
a
a
sliding action
sliding
under
action
the
under
action
the
of a
action of a
constant load.
constant load.
Okay,
Okay.
so there will be
So there will be
contact between
contact between
these two
these two
surface
surfaces
over a period
over a
of time,
period of time,
finite period of
finite
time,
period
and
of
as a
time, and
result
as
the
a result,
material
the
loss will
material
take
loss will
place
take place
through the
through the
ploughing action.
ploughing action.
And also,
And
like
also, like
it
if
depends on
it
the
depends
load
on the
actually.
load
If the
actually.
load
If
is
the
low,
load
then you
is
can
low, then you
only
can only
see small
see
small
small
tracks
tracks
along which the
plowing
ploughing has
has
happened.
happened.
If the load
If
is
the load
higher,
is
you will get
higher, you will
severe
get
plastic
severe plastic
deformation here, and
deformation here, and
the cracks
the
will
cracks
generate,
will generate,
and the cracks
and
will
the cracks
propagate
will
in different
propagate in different
directions. It
directions.
will try to
It will try
propagate
to
in different
propagate in
directions
different
under the
directions
loading
under the loading
conditions,
conditions,
depending on the loading
depending on the loading
conditions.
conditions.
So
So
generally,
generally,
in
like
abrasive
in
wear, we are
abrasive wear,
seeing
we are
this type
seeing
of
this type of
phenomena.
phenomena.
However,
However,
in
in
erosion,
erosion,
the main
the main
USP is
USP is
there will be
there
some
will be some
particle, or
particle, or
mm, like here
you
we
know,
can't
here
say
we can't say
abradant,
abradant,
rather
or rather
a particle
a particle
of a
of a
finite mass.
finite
It will
mass. It will
impinge on the
impinge on the
surface,
surface,
and
and
this
this
particle can
particle
be
can be
carried by
carried by
some fluid
some
medium.
fluid medium.
That can be
That
air,
can be
that
air,
can be
that can
water,
be
or
water,
some
or
slurry.
some slurry.
It can be
It
anything.
can be
So that
anything.
will
So
be
that will be
entrained in a
entrained
fluid
in a
medium.
fluid medium.
Okay.
Okay.
So that
So
fluid
that
medium
fluid
will be
medium
coming
will be
at a
coming at a
high
high
velocity,
velocity,
and it will
and
flow
it
over
will
the
flow over the
surface.
surface.
As a
As
result
a
of that,
result of that, that
momentum transfer
momentum
will
transfer
takes place between will take
will
place
take
between
place
the
between
surface
the
and the
surface and the
particle,
particle,
as a result
as
of
a
which
result of which
a
a
deformation or
deformation or
failure will take
failure
place
will
at the
take place at the
surface.
surface.
So
So
unless you
unless
know
you
about
know
the
about the
mechanism
mechanism
of wear
of
that is
wear that
happening,
is happening,
won't be able
won't be
to
able to
suggest
suggest
what type of
what type of
remedial actions
remedial
you can
actions you
take.
can take.
Suppose in this
Suppose in this
case,
case,
in the first
in
case,
the
in case
first
of
case, in case of
abrasion wear,
abrasion wear,
you try to
you
put
try
up
to put a
like coating
like
on top
coating
of the
on top of
surface.
the
The
surface. The
coating is
coating
generally a
is
thin
generally a
coating,
thin coating,
and it is a
and it
hard
is a hard
component, so it will
component, so it will
uh, you know
you know
resist this type
resist
of
this
wear,
type of
abrasion
wear,
wear.
abrasion wear.
Here also you
Here
try
also
to
you
put
try to put
hard
a
coating,
hard
but
coating, but
here you need
here
to
you need to
consider the
consider the
dynamic actions
dynamic
of this
actions of
particular
this
particle.
particular
Like
particle.
it
Like
is coming
it
at
is
a
coming at a
high
high
velocity, and
velocity, and like
this
this
particular surface
particular
is
surface is
subjected to this
subjected
type
to
of
this
load
type of load
continuously.
continuously.
Suppose in a
Suppose in a
pipeline,
pipeline,
the slurry
the
is flowing
slurry is flowing
continuously,
continuously,
and
and
like
like
you know
you know
like this
like
type of
this type
load
of
is more
load is more
dynamic in nature.
dynamic in
Like it is
nature. Like it
coming,
is coming,
and
and
it is
it is
impinging on the
impinging on the
surface
surface
at different
at different
angles,
angles,
and it
and
is
it is
also like
also like
moving
moving
along the
along
surface
the
also.
surface
So
also. So
that thing is
that
happening
thing is
here. Whereas
happening
in
here.
case of
Whereas in case of
abrasion,
abrasion,
this
this
particular meeting
particular
surface
meeting
will be
surface will
under
be
the action
under
of a
the action of a
constant load
constant
over a
load over a
finite length
finite length
of the
of the
surface.
surface.
So
So
yeah, this thing
yeah,
you
this
need
thing
to
you need to
be aware
be
of.
aware of.
Okay,
Okay.
so
So
yeah,
yeah,
with that we
with that
come
we
to the end
come to
of
the end of
the
the
questions that I
questions
had
that I
framed.
had
If you are
framed. If
having
you are
any
having
other
any other
doubts
doubts
regarding
regarding
today's
today's
session or
session
last
or
session,
last
or
session
any other
or any other
questions in
questions in
specific,
specific,
then we
then
can
we
discuss
can
it now.
discuss it now.
Yeah. Any
Any
questions
questions
are welcome.
are welcome.
So any
Is
questions
any
from your
questions
end?
from your end?
No, sir.
Okay, okay.
Okay, okay.
Okay, one thing.
Okay, one
Are
thing.
you
Are you
writing this
writing this
exam,
exam,
NPTEL exam for
NPTEL
this
exam for
particular
this
course?
particular course?
Yes, sir. Actually, we have to write for the academic credits for our 8th semester.
Okay, okay.
Okay, okay.
So it is
So it
included
is
in your
included in your
curriculum, right?
curriculum, right?
Sir,
So,
actually, we are having internship in 8th semester.
Hmm.
So who all are doing internship, they have to write two subjects of NPTEL.
okay, okay.
Okay, okay.
So,
So
like
like
this will be
this will
added
be
to
added
your
to your
final
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 semester
final
marks.
final
percentage.
Yes.
percentage.
Okay, so
Okay,
which
so which
books are you
books are
following
you
for this
following for this
particular
particular
course?
course?
Are you
Sir,
Are
following?
you following?
actually, now I'm not following any books. I'm continuously listening the lectures and preparing notes for that.
Okay, okay.
Okay, okay.
So in case
So
you
in
come
case you
across
come
any
across any
questions from any
questions from any
standard
standard
textbooks or
textbooks or
from
from
other sources,
other
you
sources,
can we can
we
discuss
can
that.
discuss
We
that.
can take
We
that
can
up
take that up
and discuss
and
it.
discuss it.
See,
See,
whatever I
like
am
whatever I
discussing,
am
that's
discussing,
mostly
that's
framed
mostly
from
framed from
this year's,
this year's
previous year's
previous year's
questions,
questions,
assignment
assignment
questions.
questions.
So that
So that
was
was
the
the
uh,
uh,
bare minimum
bare
thing that
minimum thing
I
that
am doing.
I
But
am doing. But
apart from that,
apart
we
from that,
can
we
add
can
more
add
value to
more
these
value to these
discussions by
discussions by
taking up
taking up
questions,
questions,
more
more
numerical
Sir,
numerical.
questions.
do we have like in final exam? Actually, up to now, what are the topics all covered? They are all like uh, it is only like theory. So, do we have any like numerical type questions
See,
later
See,
or later in the course?
yeah, as far
yeah,
as
as
I am
far as
aware
I
of,
am aware of,
it's a
it's a
theoretical course
theoretical
only,
course only,
wherein you're
wherein you're
getting
getting
a
a
diversified idea
diversified
on
idea on
the
the different
techniques,
techniques,
on the different
on the
techniques
different
of
techniques of
different
on
techniques
different
of
techniques
surface
of surface
engineering.
engineering.
So you will get
So you will
a
get a
overview of
overview of
different surface
different surface
engineering
engineering
techniques, which you
techniques
can
which you can
adopt
adopt
judiciously for
judiciously for
corrosion and
corrosion
wear
and wear
resistance.
resistance.
But apart
But
from
apart
that, you
from
need to
that, you need to
understand
understand
the
the kinetics of wear, kinetics
corrosion.
of corrosion.
So for
So
that,
for
some
that, some
introductory part has
introductory
been
part has
included.
been
Like in
included. Like
last
in
few
last
lectures,
few
you have
lectures, you have
come across
come
this type
across
of
this type of
mathematical
mathematical
formulations related
formulations
to
related to
Archer's wear
Archer's wear
rate
rate
and
and
the
the
crack
crack
propagation rate,
propagation
all
rate,
those
all
things.
those things.
So
So
yeah,
yeah,
we can
we
frame
can
some
frame some
questions
questions
related to
related to
Archer's
Archer's
equation.
equation.
We can do it.
We can do it. Like
I will look
I
up
will look up
in some
in some
textbooks and
textbooks
see.
and see.
But apart
But
from that,
apart
as
from
far
that,
as
as
I
far as
feel,
I feel,
not much
not much
numericals are
numericals are
framed in this
framed in this
subject,
subject,
as far as I
as far
can
as I
remember.
can remember.
But obviously,
But
as
obviously,
we
as we
see in the later
see in the
part of
later
the
part of the
course,
course,
we can have
we can
some
have some
interesting
interesting
problems. You
problems.
can
You can
expect this type
expect
of
this type
things,
of
like
things, like
some real
some
life
real life
things,
things,
wherein you will
wherein you
be
will
given
be
some
given some
actual
actual
scenario,
scenario,
and you would be
and
asked to
would be asked
judge
to judge
the situation,
the
like what
situation,
type
like
of
what type of
degradation has
degradation
happened,
has happened,
what would you
what
have
would you
done
have done uh,
in order to
in order
control
to
it.
control it.
So there can be
So there
two
can be
things,
two
like
things,
so this
so this
components are
components are
like
like
they are not
they are not
cheap.
cheap.
They are
They
highly
are highly
cost.
cost.
They incur
They
high
incur
cost to
high
the
cost to the
manufacturer or
manufacturer
the
or the
the company,
the company,
whoever is
whoever is
using this.
using this.
So
So
like
like
your
your
first
first
objective should be to
objective should be
prevent
to
this type
prevent
of
this type of
events,
events,
like
like
degradation events.
degradation events.
Later, like
Later, like
after
after
some amount of
some amount of
degradation has
degradation
happened,
has
at
happened,
that
at
time
that
you have
time
to
you have to
see how can
see
you
how can you
replace that
replace
component,
that
like
component,
without
without
completely
completely
using a new
using a new
component. How can
component. How
you
can you
do some
do some
sort of
sort of
surface
surface
modification to
modification
the
to the
existing component
existing
and
component
again
and again
reuse it?
reuse it?
So that is
That
not
is not
you know followed for all
followed for all
applications.
applications. But for certain applications, if you are seeing some micron level this heating has happened, then you can obviously remove that weird of surface or do some coating on top of it and again reuse it. So this type of questions can be framed, and they are, I think, a little bit critical rather than the other direct questions.
Okay, sir.
Okay, okay.
That's it.
That's it.
Thank you.
Thank you.
Thank you, sir.